change, I'd rather be it. If you don't understand it, then read it. And hit the road, Jack, you busy in this grind. Can't be blind, it's the crime, it's the desperation in these times. Life happens fast and it's precious, so please don't push us. Cause we on the edge like Bishop. Dying wishes, rights and riches. So many fishes in this pond, competition is vicious. I hear the cries from the corners of the world like the competition.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. It's one of the greatest controversies in modern times, the question of whether human activity is a cause of changes in Earth's climate. Today, we're told that institutional science and academia unite in consensus that the hypothesis of man-made global warming is no longer a hypothesis, but a science fact. Ironically, coincident with this alleged arrival at a scientific consensus, discovery after discovery have affirmed the electromagnetic connection between the Sun, Earth, and all planets. What role might this connection play in climate change on Earth, and indeed throughout the solar system? In part one of this two-part presentation, physicist Wal Thornhill explores whether consensus science is leading us toward or away from a better understanding of climate change.
Whatever happened to anthropogenic global warming? All we hear about now is climate change or global warming. There's a big difference. Climate change, including global warming, is part of the natural order. Anthropogenic global warming is an alleged consensus amongst climate scientists that we are causing global warming. But a mere show of experts' hands does not make it a fact. Modern science suffers the rampant disease of specialism. Symptom is incoherence, with experts in different fields misleading each other about the reliability of their knowledge. The distinguished historian and educator Jacques Bauzun, in his book Science, the Glorious Entertainment, wrote, "Rampant specialism, an arbitrary and purely social evil, is not recognized for the crabbed guild spirit that it is, and few are bold enough to say that carving out a small domain and exhausting its soil affords as much chance for protected irresponsibility as for scientific thoroughness. That protected irresponsibility has allowed the waste of countless billions of dollars on futile big science, like the Large Hadron Collider, the gravitational wave detectors, the pursuit of fusion power like the sun, the search for dark matter and dark energy, and anthropogenic global warming masquerading as climate change. The truth about global warming may be quite different when one or more of the premises or beliefs on which it is based is found to be false. So let's look at some of them as they relate to climate science. Astronomers believe the Earth has orbited the Sun for billions of years in its present orbit. That's a comforting assumption that ignores the fact that Newtonian systems of more than two objects are inherently unstable. Meanwhile, thousands of exoplanetary systems don't support the centuries-old model of the formation of the solar system. Earth scientists believe the astronomers, which allows them to treat the Earth as an undisturbed, isolated system receiving only solar radiant energy. So there is no satisfactory explanation for the excursions in temperature of the last ice age or the distribution of ice. Astronomers believe Venus is the Earth's twin and that something went wrong with its climate to produce the hellish conditions we find today. There is no evidence for this belief, but so strong is it that the data showing Venus radiating more heat than it receives from the Sun was blamed on the instruments carried by the landing probes. The belief ignores the copious evidence from ancient reports from around the world in which Venus is described as incandescent and as the archetypal comet. Astrophysicists mislead astronomers and climate scientists that they understand the Sun. The simplistic solar model is a century old and it predicts none of the observed features of the Sun or its behavior. Astronomers chose to believe the Sun shone constantly until the astronomer Dr. Jack Eddy showed that the solar constant has not been constant. In 1976, he published a landmark paper in Science titled the Maunder minimum, where he identified a 70-year period from 1645 to 1715 as a time when solar activity all but stopped. Atmospheric scientists have admitted they don't understand the weather systems on other planets, and even weather on the sun, which calls into question their understanding of the Earth's weather systems. I quote, "It's very disturbing that we do not understand the climate on Venus that is so much like the Earth," said Professor Fred Taylor, a planetary scientist based at Oxford University. "It is telling us that we really don't understand the Earth. We have ended up with a lot of mysteries." The weather and lightning on the distant outer planets are the most violent in the solar system. This strongly suggests that the belief that the Earth's weather systems are driven chiefly by the sun's radiant heat has missed another energy source. It is at this fundamental level that astrophysicists misinform everyone with their belief that electricity plays no role in space. So lightning experts regard the Earth as an electrically isolated system and then have to admit they don't understand what causes lightning and the huge red sprites, etc., seen stretching above storms into space. Meanwhile, magnetic ropes have been discovered connecting the sun to the Earth, which signifies electric current filaments in the plasma between them. But this doesn't fit settled science. Chris Reeve notes that the academic practice of completely ignoring claims or evidence against settled science is perhaps the most dangerous and expensive practice of the scientific community today. Unfortunately, our education systems reinforce settled science because claims against it are not presented to challenge budding scientists to think about alternative views, the lifeblood of scientific progress. Having students look for and compare the predictive successes of alternative models is an excellent way to train them to do real science. At present, the beliefs and mistaken concepts are so ingrained that scientists are blind and often hostile to alternatives. Chris writes, "Operating under the assumption that the theoretical structure is only wrong in the details, yet sound as a base for their theoretical structure, the scientific community directs the most sophisticated scientific and mathematical tools known to mankind towards a potentially endless, fruitless search for new science at the edges of their own framework. They have embarked upon a journey to prove the textbooks, and since they collectively agree on the settled claims, this search is now extremely constrained in the types of questions it can ask." The mistaken approach exhibits three crucial patterns. First, the treatment of former competing claims as settled science rather than routinely checking them against new observations. Claims against settled science are completely ignored. Alternative inferences which originate from alternative science frameworks, once a believable one is found. And third, the idea that we can simplistically rule things out in the sciences sufficient to proceed only forward, never backwards, in the manner of Sherlock Holmes. The combination of all three of these patterns into one single pattern constitutes risk-taking behaviours. These risk-taking behaviours have become so normalised by the scientific community that few even notice that the entire structure is vulnerable to collapse, or even that there exists a significant risk at all. Each pattern can be observed to be a problem on its own, without any need to consider the others. But when they become combined into one single approach, as has occurred in a number of historical instances, this is how science can spend decades or centuries asking the wrong questions. It all starts with the notion of settled science. Arthur Koestler in The Sleepwalkers wrote, "I have been interested for a long time in the psychological process of discovery as the most concise manifestation of man's creative faculty, and in that converse process that blinds him towards truths which, once perceived by a seer, become so heartbreakingly obvious. With these unacknowledged shortcomings, we have bookshelves filled with textbooks, science journals and PhD theses that would stretch to the moon, largely unread, fostering the impression that we understand most things, and the public is assailed with documentaries that breathlessly deliver and repeat fashionable, settled science fiction as fact. The broad scope of the electric universe paradigm makes it heartbreakingly obvious that climate scientists have been misled by astronomers and astrophysicists, so they have no real concept of recent Earth history, and they don't understand the real source of lightning and the electrical input to weather systems. For example, the major city in northern Australia, Darwin, was utterly destroyed in tropical cyclone Tracy in 1974. The catastrophe was described in part: at 3 a.m., the eye of the cyclone passed over Darwin, bringing an eerie stillness. There was a strange light, a diffuse lightning, like St. Elmo's fire. There was no solar energy being supplied to the 150 km/h winds at 3 a.m. in the morning. A diffuse lightning is an apt description of the slow electrical glow or dark mode plasma discharge, distinct from impulsive lightning, that drives all rotary storms and influences weather patterns. That is why the electrically hyperactive gas giant planets have overwhelmingly violent storms while receiving very little solar energy. History makes it clear that climate does change. The real question is whether our activities today are a significant cause of global warming. Climate science is not so well established, nor is the data so clear that it can blame our carbon dioxide emissions for climate change. Certainly, mysterious Venus cannot be held out as an example of how we could end up. In fact, all the evidence suggests quite simply that global warming is not man-made.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In part one of this presentation, Thunderbolts contributor Andrew Hall explored the role of electrical discharges in earthly volcanism. Hall compared the physical characteristics of volcanic fields, called the Mars of Pinacate, with strikingly similar features on the Moon, and found in both evidence for high-energy electrical discharges. In this episode, Hall considers the evidence to be found in earthly volcanism for the electrical circuitry connecting the Earth and the Sun.
In part one of the Mars of Pinacate, we looked at rim craters and their resemblance to craters on the Moon. In part two, we'll ask the question, if lightning can occur in the sky, why not in the ground? A capacitor stores the electrical charge up to a point and then lets go, like a dam breaking. It's called dielectric breakdown, and sparks are the result. Sparks are the flood of current through the dam. Lightning is one example of a spark we've all seen, but there are several types of electrical discharge to consider. Each type represents a flow of current, electrons and/or ions in an electric field. What primarily differentiates the type of discharge are polarity and surface features of the electrodes, the voltage and current density, and the medium the current travels through. Our atmosphere carries an electric field. The atmospheric field varies widely from night to day and summer to winter, between 100 volts per meter vertically in clear weather to orders of magnitude stronger during thunderstorms. Normally, the atmosphere carries a minor fair weather current of 1 picoamp per square meter. This tiny current is thought to be a return current caused by lightning around the world, diffused throughout the atmosphere. We don't notice what's happening electrically in our atmosphere normally because we live on the Earth's surface in an equipotential layer. We don't notice that is until a thunderstorm arrives. Lightning from a thunderstorm has no electrode in the sky. It comes from accumulations of charge in the clouds, pools of electrons or ions, like the accumulated charge on a capacitor plate. Temperature and pressure moved by shearing winds take the place of plates in segregating regions of charge. A study using interferometer and Doppler radar to correlate lightning with updraft and downdraft winds showed that lightning avoids the updraft core and forms in regions of weaker winds around the updraft. As a storm intensifies and the updraft speeds up, lightning frequency dramatically intensifies around the updraft. James Dye, a researcher on the study from the National Center for Atmospheric Research in Boulder, Colorado, said the findings were a surprise. The massive accumulation of charge in thunderstorms is believed by consensus science to result from static buildup caused by ice formation and collisions in the fast updraft region. So they expected to see lightning there. Instead, they found the lightning surrounds this updraft. Consensus science always requires collisions of some sort to explain electrical phenomena. Physical processes such as induction don't seem to be included in their scientific toolkit. However, fast updraft winds are likely motivated by electric current in the storm in the first place. So it is not surprising in an electric atmosphere that positive ions in a powerful updraft would collect negative charge around the updraft column, which is where they found lightning to initiate. The study indicates updraft winds won't produce much lightning until they reach 10 to 20 miles per hour. Then strike frequency escalates with updraft speed. From 20 to 50 miles per hour wind speeds, lightning frequency might be 5 to 20 strikes per minute. But above 90 miles per hour, the flash rate can exceed 1 strike per second. In consensus scientists' mind, this can only mean one thing. The ice is colliding faster. But back in the real world, the updraft should be recognized as a current with faster winds producing higher charge density. In any case, the charged layers in the cloud and the thin flashing filament we see in common cloud-to-ground lightning is only part of the event. There is also a buildup of positive charge on the ground. The ground charge forms as a pool of positive ions over the surface of the land and its features, accumulating in the highest concentration at high points. The positive ions form when electrons are stripped away from air and surface features by the electric field. The lightning bolt initiates when the negative charge invades the air below with filaments of charge called leaders. They zigzag downward in step segments, while the ground charge reaches up in a filament of positive ions called a streamer. When leader and streamer meet, the channel is complete and dumps the negative cloud charge to ground. The ionic ground charge follows, ions being heavy and therefore slower than electrons, rushing up the channel at 60,000 miles per second in what is called a return stroke. It's the return stroke we see emitting light from particle collisions in the channel. Return strokes often repeat as new charge pools and discharges, producing multiple flashes until charges equalize. It all happens very fast. You can't see these charges moving around and pooling, but you can feel it. It's called wind. Another type of lightning is positive lightning, from buildup of layers of positive ions in the tops of thunderclouds, which create arcs more powerful by a factor of 100 than the common lightning between ground and the negatively charged cloud bottom. Positive lightning also travels farther. A typical lightning bolt is about 3 miles long. A storm in Oklahoma produced a record lightning bolt that traveled 200 miles across a blue sky. The longest lasting lightning was recorded in France at 7.7 seconds. Typically, lightning will pull several times, but the total duration is less than 0.2 of a second. These record setters show that lightning can scale by orders of magnitude. In fact, we know no limit to how large it can scale. So what does all this have to do with volcanoes? Lightning is seen not only in thunderstorms, but in snowstorms, hurricanes, intense forest fires, surface nuclear detonations, and you guessed it, volcanic eruptions. There are two regions to consider in electric volcanoes, above and below the ground. Above, they are integral to the Earth's sky circuit. A volcanic plume is a dusty plasma, pyroclastic ash mixed with ionized gases. How such a plume might increase the charge density between Earth and sky is unknown. Powerful volcanic lightning is a known occurrence. Volcanic eruptions throw hot pyroclastic material into the sky. The volume of scorching hot cloud that erupts upward is not filled by the erupting gases alone. Ground wind necessarily flows inward to fill the cloud from below. This is a depiction of how a nuclear airburst detonation is designed to destroy a city. The sudden expansion of gases created by the blast rise up, leaving a rarefied region. Inward flowing ground winds reach the speed of an F5 tornado, 300 miles per hour, filling the vacuum created beneath the rising fireball and leveling anything in its path. A very large volcanic plume can have the same effect, drawing winds inward at ground level. This seems the more likely explanation for the lopsided rim and even circular areole of Cerro Colorado. It may also explain why Mar craters in general have characteristically small amounts of ejecta concentrated around their rims. But beyond the kinetic effects of the plume, the rising column of ionic material will act in the same fashion as the updraft in a thunderstorm, generating lightning around the column. At the mouth of the erupting vent, one can imagine the current flow drawing ionic charge to it from the surrounding land. This may be why rim craters occur where they do, at the boundary of the rising plume. Consensus science has concluded there are two forms of volcanic lightning. Researchers led by Corrado Cimarelli, a volcanologist at Ludwig Maximilian University in Munich, Germany, studied Sakurajima volcano in Japan, and concluded ash particles are responsible for building static electricity that discharges near ground level, as they reported in the journal Geophysical Research Letters. A separate study also published in Geophysical Research Letters of the April 2015 eruption of Calbuco volcano in Chile discovered lightning striking 60 miles from the eruption, from 12 miles above Earth. Scientists concluded the thinning ash cloud formed ice that rubbed together to produce lightning like they say a thundercloud does. The consensus narrative always needs a collision and static buildup of charge. Why this is so is hard to understand. No doubt rubbing and static charges do occur, but there is already an atmosphere with an electric field to work with, moving electric charge and oodles of ionization in these events, whether volcanic or thunderstorm. They occur in the dielectric atmospheric layer between ground and the charged plasma of the ionosphere. By assuming electrical discharge is only occurring due to localized static charge is to miss the big picture, that Earth is just one device in a circuit. Whether discharge comes only from the plume or also within the ground is the second part of the electric volcano story. We don't know much about the currents within Earth's or inner regions. We know the crust carries current. Ground current is why we ground electrical devices. So a voltage potential can't build between the ground and the device and generate a spark, or worse, a dead person whose last act on Earth was to touch the device. Ground-induced current, or GIC, is current in soil, rock, and water, as well as metal fences, pipelines, and wire. It's induced by atmospheric current because the two are coupled. Solar activity is a forcing influence on atmospheric current, increasing the dangers of GIC during solar storms. The Carrington event of 1859 was a solar flare that, among other things, produced especially energetic auroras and induced current in telegraph wires. Many lines burned up, telegraph operators were shocked and showered with sparks. Some reported the telegraph had so much current they continued working without a power source after the generators were disconnected. GIC may not be the only source of electrical current on and under the ground. After all, the rush of lava and gases through vents in Earth's crust would seem to require a lot of things rubbing and colliding. It seems necessary this would build static charge and cause discharges deep within the Earth, even by consensus reasoning. Even more likely, it's electrical discharges deep within the Earth that heats the magma, vaporizes rock, and causes eruptions in the first place. It's entirely unknown what the voltage drop is across the layers of crust and mantle to the center of the planet. But given those huge auroral currents at the poles and the puffed up magnetosphere around Earth, one should assume it is rather large. Pinacati and other volcanic fields display features electric universe theory has ascribed to electrical phenomena on other planets and moons in the solar system. Since they appear on this planet too, they need to be interpreted in the context of an electric Earth. One look at the delta Y configuration at the bottom of this MAR in the image below, and the question, is the Earth electric, is perhaps answered. In three-phase electrical transmission, delta Y connections are used to connect an ungrounded system, such as an overhead transmission line, to a grounded system, such as a transformer. The delta configuration is the ungrounded connection of three phases of current, whereas the Y connects the three phases to ground at the center of the Y. A geobotanical feature at the bottom of a volcanic crater
reminds me of an old saying when I was first being my first couple years as an electrician. The 2-wire hookup, 3-wire fuck up.
Imitating electrical circuitry may be an astonishing coincidence, or not. It may be a physical expression of how sky and ground currents couple, the same way we couple a transformer to a power line. Lest we forget the moon and the physics of electrical scarring, we can look there for hints at how subtle electrical scarring can be. And since this information comes from NASA, it's all the more astonishing. Deep craters at the polar regions of the moon never see sunlight. Within these eternally dark and frozen craters, cosmic rays are bombarding the surface, creating a double layer of opposite charge. Because it is theorized, electrons penetrate to the subsurface while positive ions hit and collect at the surface. It's always the collision thing. The double layer discharges tiny sparks that vaporize dust and launch them up to float in a thin atmosphere above the surface. This dust atmosphere was first noticed by the Apollo crews and remained a mystery for decades. There is more evidence of electrical influence in the Pinacati volcanic field and the surrounding Altar Desert than rim craters on the Mars. Some Mars that don't have rim craters appear as doublets or multiple craters with consistent floor depths. These too are features similar to the unusual shapes seen on the Moon and Mars. Tuff rings are the volcanic rim surrounding a Mars crater. Tuff rings form as hot ejected tephra falls back to Earth and lithifies into a ring of welded tuff. They are typically low relief with a gentle slope of less than 10 degrees on the outside. Several tuff rings in the Pinacati are exposed, but the crater that formed them is buried. These next four images show in order lunar-like features of tuff rings in the Pinacati. The first is a concentric tuff ring inside a tuff ring with rim features at 3 o'clock. The next is a concentric tuff ring inside a tuff ring with rim features at 9 o'clock. Third is a tuff ring with a rim crater at 5 o'clock and an east to west crater chain at 12 o'clock. And the final picture is a polygonal tuff ring doublet. Chains of raised tuff, craters, and cinder cones can also be found throughout the Pinacati.
I just got to say, a lot of these areas, people say, oh, this is proof of the, the flood and Noah's Ark and all that shit, and it's only water or wind, and they leave out the idea that it could be electrically carved, right out off the planet from, electrolysis.
Chains of raised tuff, craters, and cinder cones can also be found throughout the Pinacati. The following pictures show chains of various features, including tuff rings and cinder cones. And then there are unusual erosion patterns that seem to begin and end without reason. These are stark patterns of apparent erosion across playa that is dead flat. There's not 1 foot of elevation change. They appear to be lined with black rock. And then the Pinacati is covered.
This is evidence of that spark gap that Hitman Notoriety Brian was talking about in his videos, and he was looking for evidences of the potential balancing out between land masses or underwater as well. So
with fractal patterns and lightning bolt rills of feathery ash and tuff deposits.
I like a lot of these.
Fractal patterns appear everywhere across the Pinacati, from lightning bolt rills to feathery ash and tuff deposits. We'll look at the electrical nature of volcanic fields more.
I keep seeing seahorses in all this shit. What do they call those damn horseshoe crabs? Seahorses. What the fuck am I saying? Horseshoe crabs.
More in future articles. Thank you.
For continuous updates on space news from the electric universe, stay tuned.
Continuous updates. Hi, Becky. Put you on moderator action.
Good afternoon, everybody. Today, I'll be presenting the research work that I have been working over the last 7 years.
70 years?
The background of my work is that I have been really active in solar activity prediction as well as natural disaster. I've been doing such work continuously for 7 years. And I have discovered a lot of connections between solar activities and earth changes. And of course, found some connection with electricity and electric universe. And I would like to present this work to you today. So first thing first, the objective of this talk is going to be providing some insight into global natural disaster forecasting technique. Second is to utilize property of space and planets in explaining the current of natural disaster. And third is to explain the interaction between solar activities, planetary alignment, and how this can lead to natural disaster on Earth. So many of the things, such as planetary alignment, it's an observation that so many observers around the world have seen to be some connection, but it's really hard to explain how does it work. So I will be presenting some of the scientific experiment to help verify that this can be true, through science. So next we start with the word forecast. Forecast is about, from definition, is to predict or estimate. We want to know something in the future. And in order for someone to know something in the future, such as how each person come to this conference, of course, we have to done this type of things before. So it relies a lot of experience, practice. We actually need to know the destination where we are going and what kind of tools we are going to use and implement and actually take the efforts to do it. And of course, nobody learned how to walk since we are born. We actually need to practice. So it actually need to spend a lot of time
Jesus can speak
to
after 2 days.
develop the skill to do this. So in order for someone to make a successful podcast,
I don't believe you.
we start with looking of the subject of interest just the way it is and see what are the things that we can learn about the relationships of the two things. So first, I would like to use the picture from David Somerville and Hugh McLeod about how we actually obtain some understanding of something. So we start with data. So it's a collection of informations, and we catalog it in a way that we can make some relationship between different data. And of course, require knowledge, or in this case, we're looking for scientific knowledge to help connecting all the data, understand how each type of data or information is linked to the others. And it requires insight. Of course, we have to know where we're going. So that's very important in terms of doing the podcast. So it provides, we have to have insight that there is a path toward the goal. And of course, to accomplish all this, we have to put in efforts. So we call this a wisdom, is the choosing the right path, using the right tools, and spend efforts to make it work. And of course, the path we choose, we want to choose the shortest path. And of course, to use the tools, there are so many different tools. You want to use the tools that's the most effective. And the most effective tools in nature, we call this the law of nature, because this type of tools never change over time, unlike some scientific theories, which is based on some certain perception. It may change if we change perceptions. So in this case, we look into the ultimate law of nature, which several philosophy around the world has discovered and make the ultimate conclusions that everything that occurs in this universe happens for a reason, and that's dependent upon many things. So that means one thing cannot exist without relying on some other things to exist. And not only that, when it exists, it never lasts forever. It goes away as the factors that try to sustain its existence goes away. So the other tools I'm planning to use is, of course, the law of physics. And of course, in this conference, we talk about electric universe. So we'll be using the electrical theory to help explain a lot of natural disaster phenomena. And of course, we'll use electric to explain the Earth's interaction in local environment. And in addition to that, we also rely on wave properties to help explain things in a little bit more macroscopic. Model. So I propose to use the term quantum vibrations to explain the solar system scale interaction. And I will go over the word quantum in the future, because why we want to use this word. So next, we're going to how we do the natural disaster forecast. Of course, just like everyone's here come to this room, or Suzanne and David Tubbo set up this conference. Of course, first thing is it has to be important. Otherwise, you're not going to do it. So that means the significance is one of the factors we use in natural disaster forecasts. And of course, once we know it's important, we're going to say when are we going to do it? So that's timing. And of course, the last thing is where, which is right now in this hotel room. So the same thing for natural disaster forecast. We're looking for, once it's significance, we want to look at the timing, which is the initialization of the events, and of course, the occurrence of the events. In terms of significance, we emphasize on high damage, meaning it could have impact to human infrastructures. If it's something that happened in regular basis or consider really normal, then it's no point to do it. And the last but not least is location, which of course will be specific to different type or different zones on Earth. For this presentation, I'll be focusing on the two factors here, is the significance and the timing. And the location will be a subject beyond this talk. So next, we want to implement the basic understanding of electricity and apply it to natural disaster forecast. So the simplest way to look at natural disaster is, of course, it has to happen with a reason, and it needs some energy accumulation.
Too arbitrary for my taste right now.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Where does gravity fit in the electric universe?
Hey.
Contrary to a somewhat common misperception, the electric universe does not deny gravity's existence,
Right.
nor its role in the cosmos
So
and our own world. Rather, the electric universe theory, as proposed by physicist Wal Thornhill, suggests that the fundamental mysteries of gravity may be explained by the electrical structure of matter. In his 2008 article, Electric Gravity in an Electric Universe, Thornhill asks, when we apply force to a body, how is that force transferred to overcome inertia? The answer is electrically, by the repulsion between the outer electrons in the atoms closest to the points of contact. The equivalence of inertial and gravitational mass strongly suggests that the force of gravity is a manifestation of the electric force. Today, Bishop Nicholas Sykes further elaborates the query he first posed in his previous episode: what is the speed of gravity? And he elaborates the explanations for gravity that the electric universe proposes.
My last Space News video about the light-exceeding speed of gravity, titled "What is the Speed of Gravity?", provoked some reactions. Someone wondered if I had never heard that gravity was not a force, but a bending of the fabric of space-time. Another argued that gravity did not need explanation because it was something that was just there. Einstein's proposition that nothing can travel faster than light has become so entrenched that even some of us identifying with the EU model as a whole find it difficult to give fair consideration to the claim that gravity operating as a real force requiring a real explanation necessitates a real transmission far greater than the speed of light. Yet even if we are only at the beginning of providing such an explanation, it is important for the integrity of the EU model to adhere always to a simple force-based model for gravity, because gravity does, when all is said and done, manifest itself to our senses as a force. The electric universe model is constructed with explanations that invariably exclude just their formulations, which are, in effect, widely used agreements to discard the need for rational explanation. As a result of such agreements, the scientific landscape is littered with such follies as black holes, dark matter, dark energy, multiverses, and magnetic reconnection, all of them being just their formulations without rational explanation, designed to plug the holes in popular science theory with the unexplainable. Sir Isaac Newton understood that he was unable to formulate an explanation for gravitational attractions, even while he described the behavior mathematically of bodies under gravitational influence over vast distances with astounding accuracy. He speculated on gravity's cause, but decided to leave that issue to a future generation who might bring better tools than his to master the task. Our own generation does indeed have better tools than his, but we have become distracted from the task he and others bequeathed to us by a multitude of follies. These consist of the extraordinary plethora of the just there formulations that prevent us from accomplishing what Newton and others bequeathed to a future age. If one reads the book Relativity by Albert Einstein, published, for example, in 2004 by the Folio Society, one will see that he develops the concept of light or electromagnetic radiation being the fastest possible messenger merely by assuming that since nothing was observed to go faster than light, then there is no credibility to the idea that anything could go any faster than light. In chapters 7, 8, and 9, for instance, he assumes that information from two simultaneous flashes of lightning could never, by principle, reach an observer any faster than light speed in a vacuum. From that simple idea, the whole theory of relativity was developed, starting with the deduction that two simultaneous events in one frame of reference might not be simultaneous in a different frame of reference. The theory of relativity as conceived by Einstein depended therefore entirely on the idea that one could never make deductions about space and time that might ultimately rest upon anything going faster than the speed of light. It is therefore illogical to assert, without any other reason for doing so than the theory of relativity itself, that nothing can go faster than the speed of light. To make such an assertion would be to engage in a tautology, i.e. circular reasoning, because the theory of relativity is founded upon that assertion in the first place. Only if the theory were independently and incontrovertibly verified by observation or experiments might this be reasonable, and such is often assumed to be the case, as Einstein himself hoped that it would be. But so far as I am aware, there is not a single case of this theory's verification that may not reasonably be disputed. Under these circumstances, therefore, it is entirely scientific to consider the possibility that there may well be something observable or reasonably deduced traveling at a speed faster than light. As has already been indicated in my videos, the motion of the planets in the solar system requires that the force of gravity between the sun and its planets, assuming as we must that this is a real force and not a mental construction of some kind, must be transmitted between them at a speed many orders of magnitude faster than the speed of light. And the physicist Wal Thornhill shows also that such speeds of force transmission are just as necessary within what we call the fundamental particles of matter for the stability of those subatomic structures as it is for the stability of stellar planetary systems. Indeed, by such concepts, the physical foundation of the mathematical structures of quantum mechanics may yet be revealed and made clear in a way similar, perhaps, to the clarification of the physical foundation to Sir Isaac Newton's mathematical principles of gravitational action, that great task that he and others bequeathed to generations yet to come. In such manner, the electric universe model holds out a great promise, the promise of a physics and a cosmology that rest upon a secure foundation to replace what is taught in our prestigious schools, the current model, which, as Einstein himself discerned, relies upon two foundations, the theory of relativity and quantum mechanics, that are themselves mutually irreconcilable.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Always has those two little circles, or often morning, everybody. It's great to be back at EEU amongst old friends. I recognize so many of you from last year. Appreciate your attendance. I'd like to talk about some what we consider incontrovertible evidence that the skies are radically different nowadays than they were in prehistoric times. Okay, the top scholar of Mesoamerica had this to say: the peoples of ancient Mesoamerica keenly observed the sky and used the calendar to predict solar and lunar eclipses, the cycles of the planet Venus, the apparent movements of constellations, and other celestial events. To them, these occurrences were not the mechanical movements of innate celestial bodies, but constituted the activities of the gods, the actual recapitulation of mythical events from the time of creation. You could take that statement and apply it exactly to the traditions of ancient Egypt, ancient Mesopotamia, ancient India, Greece, the rest of the world. That is what myth is all about, describing the behavior of the gods in the sky as creation unfolded. So in the Maya account of creation, here's what it says. They fixed their eyes on the dawn, looking steadfastly for the coming forth of the sun. They occupied themselves in looking for the great star, which appears first before the birth of the sun. The face of this green morning star always appears at the coming forth of the sun. So the takeaway lines here are that the morning star appeared at creation, and that it was green in color. Those astronomers among us will know that Venus does not currently present a green color. The Maya had a hieroglyphic script, and so in their earliest writing systems, this was their glyph that denoted the great star. So this is the great star they're talking about, the morning star. And I would draw your attention to the glyph on the right, which looks like a little star or cross in the middle on like a fourfold form. But look at the four little circles in the four corners. Kind of keep that in mind as we go forward. These are two more variations upon the same glyph that are in hundreds and hundreds of Mayan hieroglyphic codices. So they're both the same sign. It's just the one on the left shows a star in the middle of the four dots, and the one on the right, it looks more like a cross. So the question is, or I guess it's pretty obvious that that sign is not recognizable in today's sky. So consequently, the top scholars in Mesoamerican studies say this is an abstract image. What does it show? Well, according to them, it shows the four different phases of the planet Venus, all of which are invisible, needless to say. So here's the top scholar in a recent book, says the fact that there are four circles in a cross-shaped frame naturally suggests the four phases of Venus associated with the four different directions. So clearly the assumption is that this is an abstract drawing that some astronomer dreamed up a long time ago. As it turns out, that image is present at least 500 BC. So they are essentially telling us that the Mayans were practicing super sophisticated astronomy in 500 BC already. Unfortunately, most of those guys have no knowledge of comparative art or comparative mythology. So they kind of overlook the fact that the exact same sign is found all around the world. So here's the exact same image from an old Babylonian cylinder seal from roughly 2000 BC. So that right there just shoots their theory out of the water, that that's an abstract sign. Here's a very similar image from the pre-Vedic civilization in ancient India. This is roughly 3000 BC. So you can see that this image is prehistoric in nature. Okay, back to ancient Mesoamerica. This is another very common sign for the great star. And again, it will be found in various different cultures down there, whether you're talking the Mayas, the Aztecs. I guess I should maybe point out which sign I'm even talking about there. But I'm talking about, whoops. Sorry about that. Kind of jumped on us. This stellar form here to the left, you will see is a fourfold star. And so that is the image that they're talking about, the ancient Mayans, when they're talking about the great star. And this particular image can actually be found on a colossal face down in Olmec times, which is 1000 BC in Mesoamerica. And these massive faces were found, not unlike the Easter Island statues. They're about 10 tons in size. I mean, they're just a massive piece of rock. And on the side of the rock, it will have that exact sign already at 1000 BC. This is a much more recent example of the same sign from the Pueblo region here in the American Southwest. And an astronomer offered the following discussion of this sign. He says, this is a common form of the southwestern four-pointed great star symbol and the sun in the center. So think about that for a second. It's not totally obvious, but if you focus your eyes, you'll see that there's a red object there in the middle of the fourfold star. And this astronomer is calling that the sun. That's his explanation. The only problem with that explanation is the sun, of course, can never appear inside a star in today's sky. So that might be your first hint that that's not going to go very far. And again, they've overlooked the fact that that exact same image is going to be found all around the world. So here's another clearer example of the same size, the same sign from the American Southwest. This is from a prehistoric petroglyph here in North America, showing the same sign. Again, I would kind of direct your attention to the dark orb in the middle and what looks like a little ring around it. Now, if we go to ancient Babylon again, we see virtually the exact same image. The fourfold star, the circular orb in the middle, only this time it's set within a crescent. And those of you that are familiar with Dave's argument on the polar configuration, you have planets in a polar configuration set within a crescent. This is an example of the same sign from 4000 BC in prehistoric Egypt, the exact same image, just a little bit different coloration. Okay, this is an object called the Quinn Cross.
It's beautiful.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In a previous Space News series, Thunderbolts contributor Andrew Hall presented his groundbreaking thesis on new aspects of electric universe geology. Of course, electrical scarring of any kind is not part of the traditional geological toolkit. In Hall's arc blast theory, he has attempted to explain the formation of mountains and other features on Earth through the principles of plasma physics and electrical engineering. In this episode, Hall explores the possible role of electrical discharges in earthly volcanism.
El Pinacati y Gran Desierto de Altar is a geologic wonderland for volcanologists. It should also be a laboratory for the study of the electric earth. Pinacati is a monogenic volcanic field in Sonora, Mexico, that lies just south of the Arizona border, 70 miles east of where the Colorado River empties into the Sea of Cortez. It is a protected biosphere reserve and World Heritage Site. Monogenic volcanic fields, meaning each eruptive feature in the field is the product of a single short eruption of unique magma, are not uncommon in North America. In fact, Pinacati is one of 50 that dot the landscape from central Mexico to Colorado. What makes Pinacati special is its pristine nature, for it is largely untouched by human hands or the effects of severe erosion. Its location in the desiccated Altar Desert of Sonora is the reason it has remained pristine. As Edward Abbey wrote of the Altar, "This region is the bleakest, flattest, hottest, grittiest, grimiest, dreariest, ugliest, most useless, most senseless desert of them all. It is the villain among badlands, most wasted of wastelands, most foreboding of forbidden realms." In other words, it was one of Abbey's favorite places. Geologists insist Pinacati is dormant, but recently so. Its last eruption is dated a mere 10,000 years ago. But local lore of the Tohono O'odham people, descendants of the ancient Pueblo culture known as Hohokam, insist there have been two minor eruptions in the last century, one in 1928 and again in 1934. Seismographic records don't bear this out, say geologists, indicating no seismic event associated with volcanic activity was recorded at the time. Its many lava flows and tephra beds portray the Pinacati as a result of three volcanic periods. First, it developed as a shield volcano, raising the mountain that gives the field its name. Pinacati is derived from the Aztec word for black beetle and is commonly used for the desert stink bug. Identity with the mountain is understandable since stink bugs hold their rear high and emit a foul odor. The next period brought blooms of pyroclastic eruption that left over 500 volcanic vents and cinder cones across 770 square miles. Its final phase created several marked craters. The Pinacati is best known for Mars and the rings of tuff they create. There are about a dozen Mars and tuff rings in the Pinacati. The crown jewel is El Elegante, 1 mile in diameter with steep sides sloping to a depth of 800 feet. It looks like a giant bottle cap was pressed into the earth to leave the depression. Its size, symmetry, and scalloped edges earn the elegant one its name. Mars are one expression of a diatreme volcano. Their creation is brief and explosive. Magma rises beneath moisture held in an aquifer, subsurface stream, or permafrost, and vaporizes the water in a series of blasts that last from a few hours to several weeks. A shallow crater with a bowl floor and a low raised rim is left over a rock-filled fracture called a diatreme. Typically, Mars fill with water following eruption, leaving a lake. The Mars of Pinacati are dry and accessible. No certainty as to the formation is truly known in consensus science. The inverted cone shape of a Mars diatreme has been generally assumed to form by shallow explosions first, followed by progressively deeper explosions. The explosions are thought to be caused by the instant vaporization of groundwater when it contacts hot magma. If deep explosions occurred first, they would hollow out a wide void, not a conical vent. But the shallow first theory should produce ejecta of shallow rock covered by later deposits of deeper rock. Examinations of Mars show that deep rock fragments are well mixed with shallow rock, implying the explosions occurred throughout all depths at once. Geologist Greg Valentine, a professor at the University of Buffalo in New York, and James White, an associate professor at the University of Otago in New Zealand, have created a new model to account for the jumbled order of explosions. Their model, published online by the journal Geology, suggests individual explosions are relatively small and shallow explosions more likely to cause eruptions than deep ones. The model did not include subsurface electrical discharge as a possible causation. Perhaps it should. The likeness of Pinacotti's craters to lunar craters made it a perfect training ground for Apollo astronauts. It's also a reason the area should be of interest to the study of electric Earth phenomena. Close inspection of craters and other features in Pinacotti reveal more than a casual resemblance to the craters of the moon. Let's take a look. Beginning with El Elegante, the Google Earth image below shows a rim crater at the 4 o'clock position, the only flaw in its beautiful symmetry. It is explained as an older cinder cone that was split in half by the Mare eruption. Rim craters also occur on other Mars in the Pinacotti. In fact, more than half of the Mars have features that appear to be rim craters. Perhaps it is normal for Mars to occur at the edge of older volcanic vents. Perhaps the older vent plays a role in creating the Mar. Or they may be what they look like, a feature caused by a filament of electrical discharge. Rim craters occur with such regularity on rocky bodies in our solar system, it is statistically absurd to think they are caused by chance impacts. They are a known feature of electrical discharge, as filaments of spark will form craters within craters and often stick to the rim of a crater previously formed, leaving rim craters. This Mars shown is 0.9 miles wide and 250 feet deep. It also displays scalloped edges and a large rim crater at the 5 o'clock position. Another small rim crater is at the 9 o'clock position. Most confusing, assuming the consensus science view of how Mars are created, is the small tuff rings in the floor of the crater beneath the large rim. In this case, the rim features can't be the remnant of an older cinder cone, since they could not possibly have pre-existed the Mars eruption. It must be the remnants of events that followed the sequence of eruptions that made the Mars. But where is the debris from this later event? This Mars, 2,400 feet in diameter by 50 feet deep, at 6:30 o'clock, has 3 apparent rim craters blanketed by inflow of red ash, as if the event flattened the cinder cone next to it by pulling it in. The next images show a rim crater at 6 o'clock and a primary crater that is 2,600 feet in diameter by 150 feet deep. The triangular wedge you see is actually a slice from a pie-shaped depression at the rim. The next images are of a Mars 3,400 feet in diameter by 600 feet deep. It shows a rim crater at 11 o'clock. Gray ejecta blankets the rim crater, but the side view shows the rim crater has a steep conic depression below the gray material. The gray ejecta is obviously associated with the Mars and blankets the slips and lava flow of the red cinder cones nearby. This appears to be the case with the other Mars, indicating they occurred in the latest series of eruptive events. However, the question should be asked whether the material was blown out or sucked in by the event that made the crater. The gray blanket is formed into dunes. See at the top center of the photo above the rim. Dunes exhibit a gentle slip to windward and steep reverse slip to leeward, suggesting at least the final winds of this dramatic event were directed inward to the crater. The best example of a rim crater in the Pinacotti is Cerro Colorado, thought to be the result of multiple blasts through several events. The main crater is 3,200 feet across with a canted rim. The lopsided rim is thought to have been created by prevailing wind depositing ejected material preferentially to the south, or because subsequent explosions caused the north side of the rim to collapse, depending on which consensus theory is chosen. Neither provides a satisfactory explanation of the rim's appearance. On closer look, it could also be interpreted that the material was drawn in, the way a tornado draws ground winds to it to create the lopsided rim. The neat, even edges and compact symmetry of the aureole around the rim appears to be caused by inflowing winds rather than the several explosive outward blasts. In the next image along the crater rim can be seen layers of deposition consistent with the effects of winds being drawn inward to the crater. There is no question that Pinacati is a volcanic field. The lava flows, ash, and tuff attest to that. We see active volcanoes around the world. The Yukon eruption on the Alaska Peninsula in 1977 created 2 Mar craters. The largest of these Mars, now filled with water to form a leg, erupted for 10 days to create a crater 1,000 foot wide. The photos show the eruption and resulting Mar. The largest Pinacati Mars are 1 mile in diameter. The largest known Mar on Earth is on Alaska's Seward Peninsula and is 5 miles wide. The magnitude of the Pinacati and Seward Peninsula events dwarf the Yukon wreck or any other eruptions seen in historical times. Consensus science does not explore the electrical nature of volcanoes and the potential effects of an intensified electric field. They should be interpreted with electromagnetic effects in mind to understand them fully. In this news article, we've looked at the physical similarities of Pinacati's Mars to lunar craters, including the distinctly electrical appearance of rim craters. Lunar craters are believed by consensus science to be formed by impacts. Pinacati's craters are a known volcanic event. Could it be their similarity isn't coincidence, but commonality of cause, that cause being electricity? In part 2 of The Mars of Pinacati, we'll look at more similarities and expressions of electrical scarring. Thank you.
For continuous updates on space news from the electric universe, stay tuned to Thunderbolts.
To find myself again, our walls are closing in. Not a sense of confidence, I'm convinced after just too much rushing. I felt this way before, so insecure. Crawling in like this, these worlds they will not hold. Fear is how I go, confusing all is real. Discomfort endlessly has pulled itself upon me, distracting, reacting. Against my will, I stand beside my own reflection. It's haunting how I can't seem to find myself again. My walls are closing in.
A study. An eventful series of papers on plasma physics were published out of Romania. In this case, a study of ways in which plasma mimics the self-organization and behaviors associated with living cells. In June of 2002, over 500 academics assembled in Boston in the USA for the 4th International Conference on Complex Systems. Out of more than 200 papers presented there, 43 were chosen to be published in the conference proceedings. 2 of those were papers by these Romanian scientists discussing just how lifelike formations of plasma state gases can seem, specifically a complex space charge configuration, or as one article casually called it, a plasma blob. Wallace Thornhill told me he prefers the term anode tuft, as seen here. The authors likened an anode tuft, or CSCC's electrical double layer, to a cell membrane, through which it acquires preferential matter to maintain its structure. In this study, here are a couple of its team members. They mention just how a CSCC will adjust itself to preserve cohesion when the charge sustaining it drops below critical levels. This plasma blob will also divide in two when current is sufficiently increased. The research team pointed out that a CSCC will make adjustments to its internal space charge configuration and its self-regulatory behaviors in order to preserve its structural cohesion in a changing temperature environment. These spheres display an observable rhythmic and cyclic nature to their self-regulatory physics, which the researchers liken to the inhalation and exhalation of organisms. Here on the 5th page of this article is a cool description of this effect in such plasma forms, for any unfamiliar with it. The authors also mentioned in this paper that a CSCC can interact with similar plasma blobs. Electromagnetic energy emitted by one CSCC in a steady state is received by others through resonance absorption. So in light of these lifelike traits, the authors have presented at multiple science conferences the idea that CSCCs might be one starting point for the eventual, increasingly complex and living forms. They might arise at the striking point of lightning, or move from one region to another colder region where new chemical synthesis is possible. And into these chemical mixtures, they bring with them likely the first regulating membrane conceived on the planet. As far as I understand their theory, the CSCC would have transferred its spatial charge configuration into future chemical forms, providing the gases and fluids of a planet with this very consequential path of expression. Whatever your beliefs about the beginnings of life on a planet, formed by many thoughts and intuitions you've assessed over the years, I hope this theory, born of laboratory experiments, excites your imagination with some fraction of the intrigue that the researchers themselves have felt.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In a recent Space News episode, we reported on two 2016 scientific studies that each serve potentially fatal blows to the hypothesis of dark matter. The first of these studies, reported in September of last year, found that the acceleration in the rotation curves of both spiral and irregular galaxies could be explained by visible mass alone, with no dark matter necessary. Professor of Physics and Astronomy David Merritt says of the findings, galaxy rotation curves have traditionally been explained via an ad hoc hypothesis that galaxies are surrounded by dark matter. The relation discovered by McGaugh et al. Is a serious and possibly fatal challenge to this hypothesis, since it shows that rotation curves are precisely determined by the distribution of the normal matter alone. Nothing in the standard cosmological model predicts this, and it is almost impossible to imagine how that model could be modified to explain it without discarding the dark matter hypothesis completely. Another study reported in December presented a statistical analysis of mini-spiral galaxies and found a so-called unexpected interaction between dark matter and ordinary matter. A co-author of the study states, most dark matter, according to the most credible hypotheses, would be non-baryonic or WIMP. It would not interact with ordinary matter except through gravitational force. Our observations, however, disagree with this notion. In this episode, physicist Eugene Begashoff analyzes additional recent studies that raise even further doubt of the dark matter hypothesis, and he explores the growing scientific case for dark matter alternatives.
Following the recent Space News episode featuring astronomer Barry Satterfield, I'd like to briefly review some of the other recent studies regarding the dark matter hypothesis. First of all, there have been news from several experiments that theoretically could detect processes involving dark matter particles. For example, the team of researchers working with Fermi Space Telescope indicates that there are no signs of dark matter particle annihilation nor decay. These processes should take place if dark matter particles could interact not only gravitationally, but also perhaps through weak nuclear force. The gamma ray flux measured by the Fermi telescope from low Earth orbit over the course of several years so far have not shown the evidence for any significant dark matter presence. Experiments on and below the surface of the Earth have also failed to detect any specific dark matter processes. There have been news from Panda X experiment in China. They've used 300 kilograms of liquid xenon to detect the collisions of its atoms with the supposedly present dark matter particles, and over the course of at least 66 days haven't detected any single event. At the same time, the article published by the team of experimenters claims that this laboratory at present is the most sensible to dark matter on Earth. Another similar experiment called LUX is also using liquid xenon, and it also have recently reported the complete absence of events of dark matter candidate detection. 20 months of observations from October 2014 to May 2016 have yielded 0 observed events. Third experiment using the same technique is Xenon 100. 477 days of data taking have not resulted in a detection of a single dark matter particle interaction. The Large Hadron Collider, which once was a big hope for finding lots of what is called new physics, have also not produced any new findings in the recent years. What it does now is basically refining the previous measurements with more and more statistics and putting more and more strict constraints on the theoretical physicist's proliferative imagination. Speaking of which, I would like to remember a story from the end of 2015 when there was a message from experimenters at LHC stating a possible detection of a 2-photon peak at the energy of around 750 giga-electron-volts. This was quickly followed by literally hundreds of papers submitted by theoretical physicists, each stating his own hypothesis on what this peak might stand for. Some of the versions included possible dark matter connection. But perhaps the most embarrassing was the fact that this peak just disappeared a few months later after accumulating more data. It turned out to be just a statistical artifact. But the social phenomenon of this theoretical physicist's rush have itself turned into the object of public and scientific attention, including some jokes and sarcastic publications. In the previous episode of Space News on Dark Matter, Barry Satterfield have already made the point that there is a more or less suitable mathematical alternative to the dark matter hypothesis, the modified Newtonian dynamics, or MOND for short. In the recent years, other theories have also appeared. Some of them are quite eclectic, trying to tie various physical concepts with gravitation. I think the most interesting of them is the so-called entropic or emergent gravity. It seems that a few people were developing it even earlier, but the most popular version of it nowadays is the one proposed by Eric Verlinde. In his paper published in 2010, he states that the amount of information associated with matter and its location could be measured in terms of entropy. Changes in this entropy when matter is displaced leads to an entropic force, which, as he shows later, takes the form of gravity. So its origin lies in the tendency of the system to maximize its entropy and is thus thermodynamic in nature and isn't actually a result of any fundamental force of nature. I'll remind that today 4 forces are considered to be fundamental, and that is electromagnetism, gravitation, weak and strong nuclear forces. In case of Verlinde's theory, the fundamental interaction that leads to emergence of gravity would most likely be electromagnetic. He also gives examples of other emergent forces such as osmosis and similar entropic forces in colloidal systems, where the fundamental interaction is clearly electromagnetic, since all the mechanical forces such as pressure or elasticity are electromagnetic in nature. Now I'll try to explain in simple terms how I interpret the basic idea of Verlinde's theory. Let us consider as an example the system of 2-point masses A and B. We always might draw a sphere centered on one of those, for example A, with the radius equal to the distance from A to B. In this case, the mass B would lie on the
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The following presentation is an adaptation of the Stephen Smith Picture of the Day article, Plasmoids Are the Power. The link to the article may be found in the description box of this video. What causes energetic emissions from galactic cores? According to a recent press release, there is a so-called supermassive black hole at the center of the Milky Way that is tearing stars apart and flinging the remains into space at speeds of 10,000 kilometers per second. The shredded stars then coalesce into planet-sized objects with masses that can exceed 2 × 10 to the 37th kilograms, or as much as 10 Jupiters. It is not from observational data that the concept is derived. It is from computer models designed to simulate someone's idea about what might be going on with the supermassive black hole Sagittarius A, should such a thing exist. Eden Gurma, an undergraduate student at Harvard University, wrote, "A single shredded star can form hundreds of these planet-mass objects. We wondered, where do they end up? How close do they come to us? We developed a computer code to answer those questions. There are thought to be thousands of, quote, free-floating planets wandering through space. Why? It is because of how stars and planets theoretically form. Protoplanetary disks, as consensus understanding sees them, are prone to collisions among their evolving clumps of matter until they settle down into stable arrangements. Some of those clumps condense into gas giants or rocky bodies, while others are destroyed. However, astronomers believe that many of these new planets are subsequently expelled from their systems. The literature suggests that free-floating planets might exceed the number associated with stars. The ultimate answer, though, is that they do not know. As the announcement from Harvard University states, those newly minted planets are probably different from those that evolved, quote, naturally. The researchers borrow a term from Carl Sagan and state that they are made of, quote, star stuff. So their ingredients will not be the same because different parts of exploded stars will form different planetary objects. The question is, how to tell them apart? There are significant problems with both ideas, protoplanetary evolution as well as black holes in general. Black holes cannot be seen by the most powerful telescopes and radiation sensors, but astrophysicists continue to maintain that they exist because of their effects. They assume that matter is accelerated and compressed until it is, quote, spaghettified, or stretched inside the so-called event horizon until it is torn apart and reconfigured into more rogue planets. Since almost all, more than 95% of galaxies are said to be home to one or more black holes, they might all be shooting, quote, spitballs at us from vast distances. Since matter spins around a black hole at extreme velocities, consensus opinions state that it heats up from friction, generating X-rays and ultraviolet light. It is those emissions that are interpreted as indirect evidence for black holes. Previous pictures of the day take issue with both aspects of this new computer model. The terminology itself is highly speculative and ambiguous. Protoplanetary disks and gravitational tides, for example, are invoked in order to explain how stars are destroyed and remade. To say that X-rays and ultraviolet light in space are created in gravity fields is to betray an ignorance. Experiments in the laboratory create those energies by accelerating charged particles in an electric field. There is no experiment that can provide evidence for matter collapse to, quote, near infinite density. Rather, Bennett pinches, or Z pinches, in plasma state material form plasmoids that then become stars. When the electric flux inside double layers within galactic circuits gets too high, there is a sudden short circuit that draws energy from the surrounding space. That energy could be concentrated from hundreds of cubic light years and then discharged in a burst of cosmic lightning, generating X-rays or flares of ultraviolet light. X-ray radiation from a plasmoid in the Milky Way's heart is the same as from stars undergoing strong electrical stresses. A plasmoid is a charged particle accelerating, so electrons spiral in the electromagnetic fields and give off X-rays. The diffuse currents then flow toward the galaxy's equatorial plane and spiral back toward the core. In an electric universe, electromagnetism is more than able to create celestial phenomena without the supernatural physics of supermassive black holes. Plasma discharge events are commonly known to generate high-energy light. The greater the electric charge flow, the higher the frequency of light will be emitted. Supply enough power, and even gamma rays are released. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. (2016) may be remembered as the year that the hypothesis of dark matter was finally, officially falsified. Two recent scientific studies report findings that may raise fatal objections to dark matter's existence. In this episode, our guest Barry Setterfield begins our analysis with an overview of the origins of the dark matter hypothesis and the significance of these new scientific reports from the electric universe perspective.
Both of these studies involve the role of so-called dark matter in maintaining the observed rotation rates of galaxies. It's these galaxy rotation rates which cause the whole idea of dark matter to be introduced in the first place. This is because the outside spiral arms of galaxies were rotating.
It's funny how you hear these silly-ass YouTubers with their appeal to authority on how this is not true. This is all pseudoscience. This is blah, 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 blah. That they never fucking show up to comment when it's going on.
As fast around the inner core as the insides of the spiral arms were. Gravitationally, it was expected that the stars in the outer arms would be rotating much more slowly, just like our planets, outside planets, rotate more slowly around the sun than the inside planets do. Because galaxies don't do that, the gravitational action of dark matter was invoked. But both articles show that dark matter was not behaving as predicted. One professor of astronomy independently concluded about the September research article regarding the rotation rates of galaxies that, and I quote, "Nothing in the standard cosmological model predicts this result, and it is almost impossible to imagine how that model could be modified to explain it without the discarding the dark matter hypothesis completely," end quote. More recently, one of the authors of the November article, Paolo Salucci, concluded that their results, quote, "make it clear to scientists that there is another sort of physics yet to be discovered and explored," end quote. So these two articles suggest that the dark matter idea might have to be questioned, or perhaps a new sort of physics awaits discovery, or both.
For historical context, let us explore why scientists first proposed the existence of dark matter.
When Sir Isaac Newton mathematically encapsulated the way that massive bodies behave under the influence of gravity, it allowed the behavior of all objects in the solar system to be described exactly. Ever since, astronomers have been using those equations in order to explain the behavior of everything that we see in the whole universe, ranging from comets to galaxy clusters. The rate at which the individual planets circle the sun was neatly described by Newton's laws and was shown to be reliable over many years. By way of illustration, a planetarium uses these gravitational laws to show what the solar system events occurred at a given time in the past or will occur at a given time in the future. Archaeologists rely on eclipse information based on these gravitational laws to date historical events. In essence, Newton's laws stated that the further away an orbiting body is from the central object that it's orbiting, the slower it's going to travel. So the planet closest to the Sun, Mercury, has an orbital speed around the Sun of about 30 miles a second. In contrast, our Earth, the third rock from the Sun, travels at a speed of about 18¾ miles per second, while the tiny and distant Pluto only travels at 3 miles per second. If the law of gravity was being followed, it was expected that the rotation or orbit speeds of stars around the nucleus of their parent galaxy should fall off in a very similar way to the planets around the Sun. In the late 1970s, Vera Rubin and Albert Bosma independently discovered something unusual about the way that galaxies rotate. They didn't behave the way that gravitational laws said they should. Instead, what was found was that outside the region of the core of the galaxy, the speed of stars in their orbits was approximately the same all the way to the galaxy's outer edge. There was no slowing, no drop-off in the orbit speed. Once this fact had been fully established for many galaxies, the necessity for an explanation became obvious. And it's in this context that the dark matter concept actually developed. Newtonian gravity did not predict these observational results, so obviously something was not being taken into account. If these flat rotation curves, as they are called, were to be explained by gravitational action alone, then it was only possible if there was a huge amount of matter in an immense halo around the entire visible galaxy and beyond. This huge halo had to extend way beyond the stars that made up the visible edge of the galaxy for the proposition to work. And since this halo of material was not visible and didn't appear to emit any light, it eventually came to be called dark matter.
Nothing bumping into
It was important to note that on this explanation, the dark matter had to interact with ordinary matter gravitationally. Otherwise, the proposition wouldn't work. In November of 2016, Dr. Andreas Ringwald defined dark matter in this way, quote, "Dark matter is an invisible form of matter which, until now, has only revealed itself through its gravitational effects. What it consists of remains a complete mystery. Although it still remains a mystery, various forms of dark matter have been proposed nonetheless, such as hot dark matter like plasma, cold dark matter like cold hydrogen gas, massive compact halo objects, which have been given the acronym MACHO, M-A-C-H-O, massive compact halo objects like swarms of planet or moon-sized objects wandering aimlessly throughout the galaxy. Extensive observations have definitely ruled out all three of those particular options. Furthermore, by late October of 2013, studies by the Kepler Space Telescope had also ruled out any possibility of dark matter being made up of black holes of any size. The possibility of it being in the form of strange or exotic matter was proposed in November of 2014, but that was because of the unsuccessful search for a likely candidate. But this is currently considered quite unlikely as a candidate for dark matter. The current favourite explanation lies with WIMPs. WIMPs is another acronym, and they are proposed to be weakly interacting massive particles, something like neutrinos. In recent scientific history, much time, money, and research effort has been expended in looking for WIMPs, and they appear to be the only possible explanation which is left. But WIMPs in the form of neutrinos and a slew of other possible particles have all been ruled out by experiment and observation. It was hoped that the Large Hadron Collider at CERN was going to discover the key elusive dark matter particle that could be labelled as the WIMP.
If WIMPs are proposed as the dark matter component, is it true that these two studies call into question whether it would interact gravitationally with ordinary matter as expected?
Yes, they do call this into question. Ekaterina Karukas, the lead author of the November paper, put it this way, and I quote, "Most dark matter, according to the most credible hypotheses, would be WIMPs. It would not interact with ordinary matter except through gravitational force. Our observations, however, disagree with this notion. If that is the case, then the original proposition about dark matter is false, since it was expected that it would interact with matter via gravity and so govern the galaxy rotation rate. The November study actually goes further. It shows that the distribution of matter and dark matter must be closely related if dark matter is really there. The authors state, and I quote, "We found a link between the structure of ordinary or luminous matter like stars, dust, and gas with dark matter." In other words, these observations show that if dark matter really does exist, it can only be in those locations where ordinary matter is present. It means that there cannot be a massive halo of dark matter extending beyond the visible limits of galaxies. The reason, according to that study, is that those visible limits mark where ordinary matter comes to an end, and so any dark matter must end there as well. In fact, in February of 2015, a specific search for dark matter halos beyond the visible limits to galaxies gave a negative result for the galaxies that were specifically studied for such an effect. So the conclusion is that dark matter can only occur in those locations where ordinary matter is found, not on its own or elsewhere. This negates the whole idea of dark matter halos existing at all. The September 2016 paper came to similar conclusions using a sample of 2,693 data points in 153 galaxies. David Merritt, the professor of physics and astronomy at Rochester Institute of Technology, who didn't take part in either study, but came to these conclusions from these scientific papers. He said, and I quote, "Galaxy rotation curves have traditionally been explained via an ad hoc hypothesis that galaxies are surrounded by dark matter. The relation or law discovered by Magor et al. Is a serious and possibly fatal challenge to this hypothesis, since it shows that rotation curves are precisely determined by the distribution of normal matter alone. Nothing in the standard cosmological model predicts this, and it's almost impossible to imagine how that model could be modified to explain it without discarding the dark matter hypothesis completely." The September 2016 paper determined that there was a precise mathematical relationship between the visible matter present and the acceleration that stars in galaxies undergo. It's an almost exact relationship or law, with very little room for error in galaxies of all varieties. The source of the acceleration or force is not identified, except that it is not normal gravity. The paper's lead author, Stacey Magor, said, and I quote, "The natural inference is that this law stems from a universal force, such as a modification of gravity, like MOND," that's MOND, an acronym again, "the hypothesis of modified Newtonian dynamics proposed by Israeli physicist Moti Milgrom. The MOND approach by Milgrom actually tries to explain the rotation curves by adding a small acceleration term to the normal Newtonian gravitational equations. This term has little effect on small scales, such as in our solar system, but it becomes effective on the larger scale of galaxies. While other gravitational phenomena cannot be accounted for by the MOND proposal, Magor's study does not discount the validity of Milgrom's approach. In fact, it is in line with it, but MOND, and here's the problem, is a purely mathematical device that gives us the right answer to some observations. That is the problem. It is only a mathematical device. There is no actual physical reason for the additional term or the new law. This in itself might caution us that we should look at other options where other accelerating forces exist apart from gravity.
An alternative candidate for an accelerating force is electromagnetism. Why has this possibility been largely ignored by mainstream cosmology?
There is, in fact, a historical reason that it's been largely ignored until recently. If you can bear with me for a few moments while we trace this through and see what happened. In the earliest years of the 20th century, a Norwegian, Christian Birkeland, was studying the behavior of plasmas in the lab. Plasma, the fourth state of matter, is created in the lab when atoms are stripped off one or more electrons, leaving protons, ions, and electrons, that is, charged particles, and they wander freely around. Moving charges like this constitute an electric current, and these currents have a circling magnetic field. These magnetic fields constrain the plasma to form filaments and sheets. So all the interactions of plasma are electric and magnetic. Birkeland's work in the early 1900s was the beginning of something known as plasma physics. However, almost immediately, a mathematician and physicist, Sidney Chapman, well respected for his work, decried Birkeland's plasma physics. His opinions were so respected that they blocked the progress of plasma physics until Chapman's death in 1970. Since then, new discoveries in space have confirmed that Birkeland was right and Chapman was wrong. As a result, plasma physics has become much more widely studied. What has been found is that over 99% of the material in the universe exists in a plasma form. So studying how plasma filaments behave in the lab can give us some clues as to what's going on in space. So from this history, it can be seen that the option of electromagnetic forces and plasma physics had barely emerged in the late 1970s and early 1980s when this galaxy problem surfaced. So gravitational phenomena alone were considered as the only option. It is in this context that Anthony Peratt of Los Alamos National Laboratories pointed out in 1992 that the electromagnetic force can be up to 10 to the 39 times stronger than gravity out in space. 10 to the 39, that's 1 followed by 39 zeros. His experiments and simulations show that the answer to the dark matter dilemma lies along this line of investigation. In a series of articles in the IEEE Journal for December of 1986, Peratt discussed his experiments and computer simulations with intertwining plasma filaments, acting under the forces of electricity and magnetism. He pointed out that at the cross-section of interaction between these filaments, miniature spiral galaxies were formed. These galaxies actually included all known types. The number of interacting filaments he used ranged from up to 12 experimentally and up to 6 in the simulations. But when using just 2 or 3 filaments, galaxies of all types were formed by their electromagnetic interaction. Peratt pointed out that these lab experiments and their results can be linearly upscaled to cosmic proportions as a result of known plasma behavior. Thus, the key candidate for an accelerating force in galaxies is electricity and/or magnetism, which, for historical reasons, has been largely ignored by gravitational astronomers up until now. For this present discussion, one important point emerges from these experiments is electricity. These lab-generated miniature galaxies, whether spiral or elliptical or whatever form they took, all had rotation curves which are exact replicas of their cosmic counterparts. The flat rotation curves resulted because galaxies were not acting under gravitational forces, but were rather controlled by electromagnetic interactions, which act in a different way, as well as being much faster and stronger than gravity. Thus, the forces involved in plasma interactions alone are capable of producing flat rotation curves in galaxies without any extra mathematical terms or exotic physics or the necessity for dark matter. Peratt's research, therefore, deserves much wider publicity among astronomers, physicists, and cosmologists than it has received up to now. So too does the answer to dark matter conundrum that he found from plasma physics to be reproducible by experiments in the lab. So it's a complete solution to this puzzle, and what is more, it's reliable science.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
to the electricity of life, brought to you by the Thunderbolts Project at thunderbolts.info. Scientific and cultural advancement involve discussion of new ideas, but before discussion can even take place, there must be exposure to those ideas. In 2 related episodes, I will present 2 theories that deserve greater exposure, each from a scientific voice that has proven their expertise before. Theories that are relevant to this group's prime focus of showcasing rarely heard ideas from the electrical sciences with surprising implications. In this case, lesser-known ideas about how life could have arisen in our planet's primordial past. In this episode, I'll be sharing a little-known theory from electrophysiologist and science advisor Robert O. Becker. From his multidisciplinary expertise, he considered how semiconducting crystals could have provided the basic patterns of life encoded into increasingly nuanced and organic systems. His exciting memoir can be viewed through a link in the description, and the following ideas begin on page 257, paraphrased here from their original order. As we walk in nature, breathing deeply of our refreshing nitrogen atmosphere, using its 20% oxygen content to complete a dance of electrons in our body. Imagine this planet with a different sky above. Picture a rocky Earth untouched by physical life, with an atmosphere of noxious gases and electrical storms. To this effect, Dr. Becker mentioned the work of Colin Graff, who theorized in 1974 that Earth's ancient volcanic atmosphere was so much larger than that it pushed the ionosphere further out, far enough that it coupled with the ancient Van Allen belts, creating a strong resonating discharge into the Earth. The ultraviolet radiation, infrasound, and additional electric energy created by this would influence chemical reactions. Furthermore, Becker argued that this added energy would complement the electrical behaviors in crystals with semiconducting properties. Crystals like quartz, which at the smallest scale of our reality is comprised of a lattice of silicon atoms interspersed with oxygen. In addition to being a growing and self-repairing structure, such crystals generate electrical current under various external stimuli. Under physical pressure, such crystals generate electric potentials, known as piezoelectricity, or due to heating, known as pyroelectricity, and in response to light exposure, they emit electrons, known as photoelectricity. The passage of electricity through such a crystal can also alter future habits of electron flow. Dr. Becker reasoned that these combined electrical traits could be a primordial analog to memory. The volcanic primordial Earth would also produce crystals with all manner of impurities, varying their electronic properties even more, creating a diversity of these self-repairing and conductive structures, each slowly evolving in its repertoire of habitual electronic responses to the forces of nature around it, and each affected by cyclical variations in the Earth's field. Eventually, they would reach a liquid crystal state and beyond, but their legacy would be cut short by the facts of nature, Becker reasoned in this model. He hypothesized that as soon as the gaseous atmosphere of Earth decoupled from the Van Allen belts, eliminating the powerful discharge between the two, any transitional life forms would be robbed of their energy supply. One more interesting detail about his theory is that the frequency of the powerful discharge resonating between the Van Allen belts and the Earth's core would be 10 Hz, according to his calculations. I mentioned the 10 Hz electromagnetic pulsation in a past Thunderblock, also based on some of Becker's thinking and recounting of history, where he recounted early circadian research at the Max Planck Institute, which discovered that when all other environmental timing cues are removed and select EMF wavelengths are reintroduced, human volunteers' organ functioning was stabilized by this 10 Hz micropulsation.
What?
Becker viewed that old observation as an elegant clue. He described it at the time as the primary frequency in the EEG of animals. He believed, based on his experience in the field of electrophysiology, that a sensitivity to that frequency would continue to mark all organic systems, once shaped largely by its influence. While Robert O. Becker had been called and trusted to some private scientific meetings to discuss matters of environment and biology. His voice and well-formulated opinions on many issues seem little known in daily public discourse. I hope this theory of his provides inspiration for scientists, science fiction writers, and a slightly changed perspective for all of us born of this earth.
This earth, I narrow it down so much to just this earth. Which is good.
In the image shown, it's a colorized simulation of a supersonic projectile passing over water. The image was produced at Los Alamos Laboratories. I've annotated it to show some of its features. The colors represent density, with purple being the background density of the atmosphere, red show high density regions, blue show low density regions. In an arc blast, the projectile is a bolide of plasma in an arc, radiating temperature 6 times that of the sun, traveling at supersonic speeds. It creates a shock wave with pressures of thousands of psi. In region 1, the bow shock strikes the land, and it's both a blowtorch and an anvil, melting, vaporizing, and ablating the land below it. In region 2 is a reflection of the shock wave. It rebounds from the land, drawing a low pressure zone behind it. The expanding gases from the blast explode into a violent mushroom cloud called a Richmeyer-Meshkov instability. In region 3 is a rooster tail, very low pressure. It follows this shock wave. This rooster tail is like the rooster tail behind a speedboat, and it sucks up the molten material from the crater and forms the core of a mountain. Region 4 are standing reflected shock waves. They resonate with the mountain's formation, and they leave distinct marks on the land, like the coherent triangular buttresses I just showed you in the last image. A closer look at region 2 shows the mushroom cloud expands in the reflection of the primary shock wave. It has the inertia of the reflected shock and the violently expanding gases to form an updraft at its core that draws supersonic ground winds from below. They flow in perpendicular to the trajectory of the primary shock waves. This violent updraft begins in the rooster tail, which draws ablated material from the blast zone and redeposits it in the wake. And here's an image of a very simple linear hill that's formed in this manner. But this process can form much more complex and larger shapes. The triangular standing waveforms created by the primary shock wave form plenums for the ground winds, directing their flow like nozzles. A shock wave is an incredible shear zone of pressure, temperature, density, and current. Standing waves don't travel. They stay in place with the energy coursing through them. I like to think of it as an entire tsunami in a pane of glass. In the inflowing winds, the shock waves are like walls of steel. In a sustained event, these triangular buttresses keep crawling outward, building outward into ridge lines, retaining the shape of the waveform that molded them. So I'll talk about supersonic waves and the effects of those, and then I'll show you some examples in the mountains that are exact replicas of these waveforms. Supersonic waves are longitudinal waves that expand behind the projectile. The angle they make between the trajectory and the shock radiation is called the Mach angle. The Mach angle is proportional to the Mach speed of the projectile. So if you can look at a landform and determine the original incident shock Mach angle, you can get information about the speed of the bolide that created it. When the shock wave strikes ground, it reflects at an angle relative to the angle of attack of the Mach and to the Mach angle. So again, the relative angle, or the rebounding angle will give you more information about the trajectory and speed of the shock wave that created it. Standing triangular waveforms created by reflection are an inevitability of the event. The wave travels on a transverse carrier wave called the propagating wave. As the shock rebounds, some of its energy is absorbed by the surface, and some of it, most of it, is rebounded. The energy of the shock dissipates over time in a predictable way. As the mushroom cloud rises, drawing supersonic ground winds through the shock envelope, the winds provide sustaining energy and they keep it alive. So this set of standing waveforms gets created, and as the energy is reverberating through it with these supersonic winds, it's resonating, and that's a source of free energy to this vacuum cleaner that's sitting over the land. Shockwave behavior has been studied for years. If the projectile changes direction, the shock radiation does too, in predictable ways, resulting in new shock reflections and expansion and compression of the waves. Shock waves can fragment, creating expansion fans. Excuse me. Or they can reflect off of each other, creating new reflections. New reflections continue to form like a hall of mirrors to the nth degree until the energy of the shock dissipates. The propagating wave is a transverse wave that vibrates the land seismically. The shock wave is a longitudinal wave, so it compresses and expands like an accordion. The resultant waveform that forms over the land and forms this shock envelope is a superpositioning of longitudinal and transverse waves. So the pink waveform at the bottom is the resultant waveform that forms the shock envelope. Expanding and compressive waveforms are embossed on the flanks of mountains exactly as they were formed by the winds of the shock wave. This is an image of a mountain that's in China, and it shows the expansion and compression on the waveforms. This is an image of a mountain in Argentina that does the same thing. The amplitude and wavelength change inversely with frequency. This is a property of waves. The waveform always meets at the base to form a continuous row of triangular buttresses. Mainstream science has sort of an explanation for these features. The land expands and slip faults form, and the broken land rises into mountains and falls into valleys. It's called the horse graben model. And it's used to explain most basin and range regions. Then seismic waves are theorized to roll beneath these mountains and create features that some have interpreted as these triangular buttresses. Mainstream theory says earthquakes deep below form longitudinal P waves that rise to the surface, and transverse S waves that rattle the ground like that. And the result is an undulating surface wave. On the lower right, there's two surface waves shown. One's called the love wave.
All right, take care.
The love wave ostensibly jumbles fault blocks into triangular forms like we're seeing. And the Raleigh waves are believed to compress and expand fault blocks into a rolling shape. In both cases, it requires fragmenting of the mountain into these small fault blocks, like child's blocks that get jumbled around. I don't know, but how such seismic rolling waves beneath the mountain could roll beneath and form triangular buttresses that wrap around the end like they're shown on this mountain. If a wave, a surface wave, is rolling beneath this mountain longitudinally, it's going to keep on going in a straight line. It can't turn around and wrap around the mountain and keep forming these waves. Now, there's another possibility, and that is a shock wave that comes from below. And it would have to come basically below this mountain and send these radial waveforms up the side. But that doesn't really make sense. It doesn't comport with what we see. The triangular buttresses are layered in place. Seismic waves can explain buttresses that are layered in place. There are no fault blocks here. Buttresses are stacked layers blown into place by hot supersonic winds. You might think, well, this is an ancient beach or sedimentary layers of an ancient lake that have been uplifted and somehow serrated into triangular waves. But no, these are vertical buttresses in Mexico, and they're all granite. So it's not an ancient beach. It's not sedimentary. These are layered in place by supersonic winds. You'll find them at a low repose in some strata, and you'll find them almost vertical in areas like this. You'll find them in sandstone, you'll find them in granite, you'll find them in every type of rock. Excuse me. Evidence so far also suggests that most of these buttresses are layered in place in a molten state. And this image shows the putty-like formation as they were blown into place. Proof that winds form buttresses is evident in this picture, where one mountain has canceled the one behind by blocking the ground winds. The coherence of this landform is undeniable. Buttresses face perpendicular to the wind direction because the reflected waves are parallel to the trajectory of the shock wave, and they form windows for the winds to flow in radially, normal to the shock wave. More evidence of wind formation is apparent in the stratified layers of pressure ridges that form concentric rings around the mountains. These pressure ridges can be seen to stack in one way on one side and stack in the other way on the other side, clearly showing two different wind directions coming to meet at the mountain. The amount of energy absorbed by the substrate is apparent too in the waveform. Hard substrates reflect sharper angles like these, and soft surfaces.
Now he uses the word wind a lot, but and that might be misleading as to the way, you know, if you didn't hear what he was saying earlier about it being a massive shock wave, this wind, not just some wind. And yeah, I'll just leave it there because that's the kind of environment you'll end up with in the middle of an electric discharge.
Have a lower modulus of elasticity and absorb more energy. They also feed back vibration out of phase to the shock envelope, creating rubbery looking buttresses like these. Now here's a mountain core that looks almost totally incoherent. And yet it has these perfectly formed, coherent, sorted, and layered waveforms welded to its flanks. I mentioned before that shock waves press against each other in compression. And here's an example of where a waveform is squeezed by its neighbors into a semicircle.
Yep.
In the next layer, it's been canceled out, and the adjacent waves have joined wavelengths to fill the gap. Even more compelling evidence of triangular buttresses are the result of that they are the result of shock waves is harmonics. Harmonic waves always form an integer multiples within the fundamental or original wavelength. Shock wave harmonics are created by instability. This is a Schlieren image of a wind tunnel test that demonstrates. In the first frame on the top left, the speed of the wind is Mach 2. As the frames progress, the wind slows and instabilities form. Vertical waves called normal shocks are forming. They are standing waves as well, but they slowly migrate through the triangular reflected waves as the speed of the wind changes. Normal shocks interfere with the triangular waves and cause them to shatter into multiple reflections. In the last frame, you'll see 7 triangles. We're at Mach 2 in the first frame, there's 1.5. Note the angles of the reflected waves have changed, the frequency has gone up, and the amplitude has gone down. So here's an example of the normal shocks that migrate, and they were impressed into the mountain core. The triangular buttresses are stacked below it, but they're on top of these. These slices don't cut through. So the triangular buttresses were blown in after these normal shocks passed. The normal shocks are parallel and almost equidistant across the mountain core. They're close to vertical, but in this aspect, they appear a little bit more angled than they really are. This is another example that shows normal faults and some very pretty mineralized layered harmonic waveforms. Now I'm going to switch over so I can show you. Right here is a normal fault, and you can see it slices right through the buttresses that are formed in the center here. You can see it all the way down the mountain. Right over here is a second normal fault impression. It's a little bit distorted because there's this erosion canyon over here, but you can see at the bottom, and you can see it beginning at the top. But in the center, it's covered over by the waveforms. And then right over here is another normal fault that's hardly discernible because it's almost completely covered over from top to bottom, but it's there. Each of these, again, is parallel to each other, same shape, almost equidistant. But what's unusual is that this waveform happened after these were created. This one happened before these were created. So there's a temporal relationship between these normal shocks as they pass through and the buttresses as they were layered in place by the winds. Here's a set of harmonic reflections in a soft substrate in North Africa, and this shows the harmonics. Each major waveform breaks down into 2 or 3, and then each of those break down into 2 or 3 or 4 or more. These mountains have reflections everywhere. Note that the ridge lines build outward until the waveform shatters into harmonics, and those can continue to build smaller ridges. Here's another example of the harmonic formation. And I'm going to switch here again to be able to point this out. First, you have the large waveform that comes across here, even extending out of frame. Right here is where a normal shock is hit right at the apex and left an impression and caused this waveform to shatter into these 7 harmonic waveforms. Now, there's actually an 8th, but it goes out of frame. Then each of these 7 waveforms shatter again, so you get multiples of 2 or 3 or more in here. And right here I've circled where 7 tiny little waveforms have formed in a straight line within the wavelength of their parent. Here's another good example of how the waveforms shatter before they form a new layer. Because in this one, I'm going to have to go back to the, show you what I'm talking about. Where the arrow is right here, this last layer, before it shatters into these harmonics, has started to serrate because the harmonic reflection has begun. And you can line up the apex of these serrations with the harmonics below. So this buttress was layering outward, and then it started to shatter, and it serrated the edge just before it broke into harmonics, into a new layer. With sustained energy, the wave envelope acts as if it's alive, building ridgelines that cancel each other out, jostle each other around, and split into harmonic multiples. Here, the center ridgeline is canceled by its neighbors. A normal shock has passed through, and you can see its progression in a stepwise manner, creating zigzags across succeeding layers and causing the waves on the left to expand and cancel the center wave. This is where the normal has passed through, migrating through, And it creates kind of a zigzag because it makes an impression here as these layers are being formed, and then it jumps over here as these layers are being formed. So that's the zigzag pattern as this normal shock went through. It canceled out this center ridge line, and this ridge line widened to take up the space. Note how ruler straight these waveforms are on the outside of these ridge lines. They remained unchanged as this cancellation took place. Doesn't want to respond to my finger for some reason. These harmonics look like the embroidery on a shirt I wore back in the early 70s. The material is layered and sorted according to its dielectric properties by the electromagnetic fields that are the engine for the big Kirby vacuum cleaner that created it. Now let's see if you're as good as I am at seeing Jesus in a piece of toast.
Okay, today we're going to be looking at
The world is
no. All right, this test we have carbon black on the table. And again, we're using a DC current and acrylic sheet. And we'll slowly sweep through this voltage. See what we get going here. What's that? What we got? Here we go. Something to about 20, 30,000 volts there. What we got in the movement, motion. You can see the patterns emerge. Surprised, I thought this would be much more violent on the acrylic. I don't have it wide open, it's about 55,000 volts there. Keep going. concentrically around this reaction. We begin to build ridges. Surprise, none of this is actually leaving the acrylic sheet, or very little. There's some on the table. It's at the corners. About 70,000 volts right there. 0.8 amp input into the transformer. What's up, YouTube? MR2 here. Got some little science project set up here, man. You're gonna take a look at the electromagnetic current, the static charge in our atmosphere, and how static electricity works, and its effects on our planet. The fact that they don't have any real explanation for what effects that we can see here that static electricity does actually have on this planet. And they call, the difference between gravity, and we're going to take a look at, gravity and electricity and see if we can figure out the difference. Good buddy is here to get well present right here, man. This is pretty awesome. It's a levitating globe, but I just set it up here so we'd have something to look at, because I ain't all that pretty. At any rate, just the Earth itself, the crust of the Earth is made of 90% sand, silicon, which is glass, which is a highly insulated material. And on the list of static items that'll hold a static charge, rubber, glass, these things are very high on the list. In fact, a balloon, the surface of a balloon is rubber. It acts as a good static charge or capacitor, whatever. It acts it's actually close to the makeup of our crust. And when you see the amount of electricity that flashes through the clouds and the lightning, you can take a look at some of this footage here. You'll see that we have massive amounts of electrical charge on our planet versus a balloon. But at any rate, let's take a balloon. I got a bag up here. So let's take one and blow it up so y'all can see, because this ain't nothing tricky here. Yeah, I know. Y'all can say it in comments. Look at here. You take the balloon, now it's already going to have a static charge as soon as you blow it up. But you can rub it on your shirt, on your hair. If you rub it on your shirt, listen to it, be quiet. You can hear it start popping and snapping. Those are little arcs of electricity popping between, just like lightning in the atmosphere of the Earth. And even, at that scale, I would say it's pretty close, because, you got to think a lightning bolt on the planet from way back here. It's just a very little small spark, just like it is right here on my shirt. And you rub it on your shirt till you start hearing that. And the same principle is applied here. Is that the friction is causing static electricity to build up, or catching free electrons from the atmosphere, which always comes from the sun anyway. So and what I'm doing on the outside is the molten inner core of the Earth is doing on the inside. It's doing the same thing, same processes as this, same friction, capturing of the electrons from that, from its source, which is the sun, which is going to supply source to this balloon and this planet and the you and everything else. Nonetheless, the static charge
it's a magnetism and electricity, and the fact that it has an effect on anything is what's so amazing about it. It's not just metal that it attracts. In fact, we're going to see here. I'll show you through these things we got set up here. You know, got a piece of cereal, paper clip. If you can see that, right there. Then we got a piece of leather strap, and a piece of plastic. And this is just a little magnet. It's got a north and south pole on it. Be curious to watch that one. A piece of paper, and here we have a piece of electrical tape. And so we'll take a look at this. Watch what happens when you bring this too close to this piece of cereal. It's going to have an attractive force, and in fact, it's going to try to pull that piece of cereal right over till it touches it. Doesn't matter which side of the balloon you use, it's going to stick to it. That doesn't matter what it is. Do it with the we may not even be able to do it with the paper clip because the damn cereal is going to get big. At any rate, you can see that paper clip, it also has an effect. It'll pull it right over to it too. Anywhere around the balloon, it doesn't repel it. There's a second one. We'll take this piece of leather. You'll see. Same effect. Doesn't matter what it is, it still attracts it. We'll go to this piece of plastic. You'll see. Doesn't matter what it is. It's going to pull it over there. What's better on some of the others, but nonetheless, you see this definitely has its charge to it. It'll go with the magnet. Of course, you can see that little piece of paper back there is just jumping all crazy about the magnet, the paper. But I think there's nothing here that this doesn't have an effect. And that includes water. Take a look at this here. And you could do this at home too. You'll see that water's going to try to jump right out of that sink. Go right to that balloon. I mean, you can hold the balloon down here and ground it to the sink. It's still going to attract it. Just, you know, static charge. If this static charge around this balloon, as weak as it is, will bend water or attract water, make water stick to it, then you know the electrical charge that we see around our planet with the amounts of lightning that we observe and the magnetic field that we observe is much greater on that scale than it is on this one. And to say that water is on that planet because of an inner force rather than an outer force is hard to believe now. And you know, as above, so below. There's not a thing on this planet that's not attracted to that balloon, that static charge. Just like that is the one that's on our planet. And I got this one wet. So over another one, I'll show you something else. And the fact that the way these objects will align themselves, I mean, did the magnet have anything to do with the balloon? Everything's attracted to electricity. Everything. There's not a thing here you can't do this with. Here's water. Got some shavings, wood shavings from outside. Some plastic shavings, PVC, wood shavings, whatnot, such as that. This gets charged on this. It's already got 30 gallons. Some balloons, fresh out of the bag, they got a real good charge on it. Nonetheless, it's the engine that turns that keeps the whole thing going. And ready to put things down. You can hear it picking up the particles immediately. And what we'll do is take a look at this. Now you notice how whether it's plastic or wood shavings, it don't matter, it sticks right to it. But look at the orientation. Look how everything wants to stand straight up like a tree. like you and me. Isn't that something else? And the fact that scientists don't, you know, that this scale, we should have some explanation or some sort of scientific explanation for what effects this should have on our planet. And yet we're told it's gravity. That's it. They don't have any other explanation as to why this happens on Earth. That, you know, the reason they give for this balloon is totally different than the reason they give it for that planet. When in all actuality, as above, so below, they're doing the exact same thing. You know, you can take a magnet. So you don't even want to leave me. You can take a magnet and anything really, you'll see magnetism is much stronger than gravity. There's a tuning fork here. And you know, as we're talking, the Earth right now is pulling down on the fork. If I let go of it, you know, the Earth's pulling down on that right now with all its force and all its might. The Earth's pulling as hard as it can on that tuning fork. Yeah, there's a tiny magnet here. It's strong enough to overcome the whole force of this Earth. Pick that up. Overcomes gravity. Billions of times stronger than Earth. Think about that. Think about that scale. Keep that scale in mind. The entire Earth is pulling down on that. This tiny little magnet, which is 100 millions of times smaller, smaller than the planet, yet it has no problem with it. So what we're being told and what we're being learned is obviously not the case. At any rate, I thought that was pretty cool, man. Put that video out.
I did too, buddy. Thank you.
Tell everybody to appreciate it, man. I feeling much better, man. A lot better. Still can't move out over here too fast, man.
Take a careful look at this unstable waveform. It's being pinched in at the top around this circular feature. And harmonic reflected waveforms are forming triangles down at the bottom below that circular feature. The feature of a circle is a low density feature. Now look at this buttress in northern Arizona. It's almost a spitting image of the waveform. There's the hole where the low density region is. It's pinched in at the top, just like in the Schlieren image. And you can see the waveforms, triangular buttresses that have formed below in almost the same configuration. So I'm going to back up so you can take a look at that again.
It'd be hard to deny that one.
If I can figure out how to do that.
That is a signature.
There. Take another look at the hole, the pinching, triangular waves below. And take a look at the hole in Arizona. These low density holes are quite common. If you look around, here's one in Iran. This is where two holes have begun to form in succeeding layers on these buttresses in Utah. Now here's another test for your pattern recognition abilities. This is a road cut in Iran. It's not a triangular buttress. This is a completely different shock feature. This is where the initial bow shock rebounded from the surface of the land and folded into its reflected wave.
Up under.
There are particular morphology of this reflection at the boundary layer. As shown in this diagram, excuse me. I think I'm going to have to switch again. So this is the boundary region reflection of a shock wave. This is the incident shock coming in, and it takes this kind of a curve downward as it bends and reflects. And then the reflected shock is coming back up almost straight. The reflected shock forms some expansion right here, which creates these transmitted shocks down here inside the wedge. These transmitted shocks, you can see, have a dip to them. Also, another feature is the lambda foot right here at the bottom. This is the bottom of the reflection where some of the energy is dissipated into the soil below. And I've also annotated in red myself because, thank you, because it was not on the original. I don't know how to do this with the microphone. Thank you very much. I've also annotated that was not on the original diagram another shock feature, which comes down here normal to these transmitted shocks. So take a good look at that diagram. Oh my, get my finger to work. Here's another image of this. This is the same road cut in Iran. It's just a different perspective that allows you to see a little bit clearer the features. And almost every feature is here. This is the incident shock curving downwards and reflecting back. The reflected shock is almost straight. This is the curving transmitted shock. Lambda foot's right down here.
Take your word for it.
I'm going to go back so you can take a look. This is the original photo I showed.
Thank you.
A little bit closer up. Oh, and I failed to mention the transmitted shocks right here have also formed the same dip in the wedge. Now, if pattern recognition isn't your thing and you don't trust in that, don't trust what your lying eyes show you, how about some theoretical physics and differential equations? Dr. Mark Boslow is a physicist and a geophysicist at Sandia Labs. He's a recognized expert on airburst meteors. He studied Chelyabinsk and Tunguska. He and his team used Sandia's supercomputers to simulate an airburst meteor. Here's Dr. Boslow in front of his simulation, pointing to the region of the mushroom cloud, where the inflowing winds are actually coming in at the ground. He's a graduate of Caltech and Colorado State. He's a made guy in the mainstream. He has YouTubes, popular articles, and peer-reviewed papers to his credit. He's a gravity guy. He gives TED Talks on the dangers of global warming and advocates against global warming deniers. So I doubt he's going to come to an Electric Universe conference soon. But his insights and his work are directly applicable to arc blast. An airburst meteor, as he defines it, is when a cometary fragment or an asteroid enters the Earth's atmosphere and it blows up in the air. But it doesn't fragment into pieces of rocks that hit the ground. It atomizes into a plasma bolide. And that plasma bolide continues in the trajectory of the projectile that it came from, pushing a shock wave in front of it. And it's that shock wave and plasma that hit the ground and create the airburst features. And that's what he speculates happened in Tunguska. And he's probably right. But he hasn't looked at all these landforms because the features that are created, the triangular buttresses, the ablation zones, the pressure ridges, they're all evident on this mountain here. And it's in Syria. It's a 100-mile long curvilinear mountain. And there's no way that a projectile coming from space can create a curvilinear mountain. Nor can it create 90-degree radial bends like these in Siberia. Nor can it create diverging paths like these. Nor can it do a sudden change in direction. Now this is in Iraq, this astrobleem, and it looks like two different ones, but it's actually one. You can look very closely. There's connection between in the middle, but it's a sudden change in direction. And there's no way that a cometary fragment or asteroid could do that. Here's a set of astrobleams that apparently all happen simultaneously, but they're pointing in different directions. I can't confirm to you that these all happen simultaneously, but if we had the field work to do it and to go out and look at these blast zones, these ridge lines, the shear zones between them, I believe we could determine that it was a simultaneous event. The other thing are mountain arcs, continental-sized mountain arcs. Triangular buttresses, expansion fans, all these features I've been talking about, you can find.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. 2016 was another exciting year in space discovery. Like every other year in recent memory, major surprises dominated science headlines. From the detection of X-rays from Pluto, to the possible falsification of the hypothesis of dark matter. However, science media also declared some victories for the standard cosmology, most notably the purported detection of gravitational waves. In this episode, the Thunderbolts Project's chief science advisor, physicist Wal Thornhill, offers a perspective on the current state of science and the electric universe as we enter 2017.
On every New Year's Day, I wonder whether this will be the year the Thunderbolts Project and the electric universe gain significant mainstream media attention. I think 2017 offers the best opportunity yet. There are two reasons for saying this. The first relates to our Sapphire project, and the second to human nature. Let's take the Sapphire project first. Sapphire is an electrical experiment far more sophisticated than the one that Christian Berkelin carried out over a century ago, in which he subjected a magnetized globe suspended in a vacuum chamber to electric discharges. He called it his Torella, or Little Earth. Berkelin discovered the foundations of the electric universe, but mathematical theorists who had no use for such a complicating factor as electricity ignored him. Berkelin's story by Lucy Jago, The Northern Lights, is well worth reading. So today you'll find no mention of electricity in any textbook on astronomy or astrophysics. It is a failing that ensures the 20th and early 21st century will be remembered only for its odd beliefs. If Sapphire is successful, and all indications so far point that way, we will, for the first time in history, understand how the sun really works. And since the sun is our touchstone for understanding all other stars, such an understanding must revolutionize cosmology. Stars are not isolated nuclear campfires in the sky. Scientists a century ago, effectively in the horse and buggy era, grasped upon the recently discovered nuclear energy to explain how a star might keep shining for the eons required by the misguided gradualist theories of geologists. Sir Arthur Eddington invented a simplistic gravitating ball of gas model of the sun. But the sun is an almost perfect sphere, which is impossible if gravity shapes its rotating body. Particle physicists joined in the game and invented a complex and unverifiable sequence of nuclear reactions requiring that the center of the sun be composed of the lightest gas, hydrogen. This profoundly unlikely condition has remained unquestioned despite the fact that almost every observable feature of the sun denies Eddington's model. And there is no feedback mechanism known that could control hydrogen fusion to within 0.1%, which is how steadily the sun shines. The hydrogen bomb model of star should have the night sky look like the 4th of July. So what if we don't understand the sun? Well, it changes everything. It means scientists are wasting billions of dollars trying to generate energy like the sun. It means the trillions of dollars spent on the Large Hadron Collider, on fusion research, on gravity waves, on astronomy and space research is largely wasted. The questions being asked are the wrong ones, and the data is being misinterpreted. The modern mysteries to be solved are not real. They are artifacts of the models. The computer models are incorrect. Big science today is a train wreck in slow motion. Big Bang cosmology is our atlas of the universe, depicting our place within it. But our cosmic atlas is little advanced beyond a medieval map. Instead of being centered on the Mediterranean, it has a geocentric perspective. Experiments on Earth become consecrated as universal laws and universal constants. The universal law of gravity, for example, has unexplored regions populated by monstrous black holes which swallow all that comes near. It has an edge beyond which one cannot go. That edge follows logically from a mythical beginning called the Big Bang. But the concept of an edge requires there to be an outside, which defies the meaning of universe, which is everything that exists. Trouble is, the Big Bang is only required by the universal law of gravity to primordially blow everything apart. Why that initial state didn't constitute a black hole is not explained. The Big Bang universe is unstable because of the tendency for everything to fall back in again. I use the words law of gravity because that law is merely an equation, while gravity itself is not understood. The necessity to introduce imaginary dark matter and dark energy to save appearances is evidence of this. Mathematicians need to assume that the law is universal and that gravity always behaves as we experience it here on Earth. Otherwise, they're out of business. Clearly, this is a belief driven by necessity. It's not science. So it's no surprise that the Big Bang creation myth was born as a kind of restatement of the creation story of Western cultures by Georges Lemaitre, a Belgian Roman Catholic priest and astronomer. It seems we need a cosmology that addresses our existential fears and makes us feel safe. But safe from what? That is the question never asked by scientists today. As the Australian philosopher David Stove wrote in his book, Anything Goes, Newtonian physics is a guarantee against the occurrence of just about anything disagreeable. This brings me to human nature. The last revolution in science occurred in the time of the upheaval and chaos of the First World War. You may notice I didn't say scientific revolution, since there was very little about it that was scientific. The Copenhagen interpretation of quantum theory is probabilistic. It disconnects cause and effect, disregarding a fundamental principle of physics. And Einstein's relativity removes the absolute frame of reference essential for measurement in physics. For example, if two clocks are moving relative to one another with velocity v, there is no way of special relativity theory telling which clock is ticking slower than the other, because all you have is a single piece of information, v, that is symmetrical for the two clocks. So much for the twin paradox. It ain't physics. So it's no surprise that these two theories that are supposed to be the pillars of modern cosmology, one at the subatomic level and the other at the cosmological scale, are incompatible. It's astonishing that science can be as impervious to self-correction in this modern era as it was when the Earth was thought the center of the universe. Newton was right. Celestial bodies know each other's positions instantly, in defiance of Einstein's speed of light prohibition. Quantum spooky action at a distance and entanglement show a similar instantaneous resonant connection between separated matter. There is a universal time. What physical clocks do depends on where they are and how they are moving with respect to other bodies in the universe. But it seems we need another revolution before scientists will give up their computerized virtual reality and return to physics.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A new scientific paper suggests that lightning on Earth may be vastly more powerful than conventional science has ever suggested. Investigators sought to answer how much energy is in a terrestrial bolt of lightning through the study of fulgurites, which are hollow glass tubes that form when lightning strikes soil, silica, sand, or rock. To their surprise, they found that the lightning that formed some of the fulgurites had far more energy than is expected of earthly lightning. In his web article, "There's way more energy in a bolt of lightning than we thought," Matthew Pasek, associate professor of geosciences at the University of South Florida, states of the findings. When we looked at these fulgurites in depth, something odd came out of the data. Our energy measurements followed something called a log normal trend. Rather than following the bell curve we often see in the distribution of natural phenomena, the large lightning strikes were much larger than the average, while the smaller strikes were not so much smaller than the average. Strikes that were twice the average were as frequent as those that were half the average. Pasek continues, based on our calculations, how close does Hollywood come with estimates likened back to the future of 1.21 gigawatts of power in lightning? Power is energy per time, and our measurements of fulgurites suggest that megajoules of energy make rock in thousands to millions of seconds. So a gigawatt is actually on the low side. Lightning power may be 1,000 times that, reaching into the terawatts, though the average is probably tens of gigawatts. The research was conducted in Florida, which receives more lightning than any other state in the US. However, any lightning occurring on Earth today may be only trivial in comparison to past, extraordinary electrical events that are no longer occurring in our solar system today. The position of the chief principals of the Thunderbolts project is that in the relatively recent past, perhaps only several thousand years ago, in a period of chaos in the inner solar system, violent electrical discharges between planetary bodies dramatically altered the surfaces of several planets and moons, including the Earth. As repeatedly outlined on this series, experiments with electrical discharges have successfully reproduced countless familiar geological features. Intriguingly, this latest research is not the first recent finding to suggest that lightning's power is far greater than consensus science has ever suspected. The 2014 National Geographic article, Lightning Can Shape a Mountain, outlines the research of geomorphologists into the effects of lightning on the Drakensberg Mountains of southern Africa. The research found that, quote, lightning, rather than ice or heat, is the main force shattering rocks on Drakensberg summits. The lightning is said to have destroyed basalt rock face and scattered as much as 10 tons of debris dozens of feet. The electrical discharges have formed pits up to 3 feet deep and have reportedly moved boulders the size of a small truck. Evidence for shockingly powerful lightning has been found on other planets as well. Earlier this year, scientists expressed their amazement over the completely unexpected discovery of the mineral tridymite in a Martian crater. Tridymite only forms at super hot temperatures and is normally associated with volcanic activity. But Mars is not known to have the dynamic subsurface plates that are thought necessary to create volcanic activity. NASA planetary scientist Richard Morris said of the discovery, "It was the last mineral we expected to see. If this stands the test of time, it has a lot of implications for how Mars evolved. We may have to rethink a few things." The discovery is so problematic that investigators said that they're now trying to discover ways that tridymite can form at much less than superhot temperatures. But could the Martian mineral have been formed by extremely powerful electrical discharges? As noted in a previous space news, tridymite has been reported as a product of lightning on a roofing slate in the book, The Data of Geochemistry. If the electrical catastrophes that we have proposed did in fact occur, then high-energy electrical discharges would have removed enormous materials from Mars and other planets and moons, producing many, if not all, of the observed comets, asteroids, and meteoroids in our solar system. In fact, many recent scientific discoveries provide clues to these past events, though institutionalized science has yet to connect the pieces of the puzzle. For decades, scientists have puzzled over the origins of glassy beads found in stony meteorites, called chondrules. The theory of meteorite origins in a primordial dust cloud did not allow for the extreme heating and sudden cooling required for the chondrules formation. However, in his 1988 scientific paper, Formation of Chondritic Meteorites and the Solar System, physicist Wal Thornhill proposed that intense electrical discharges were the process that formed the chondrules. Today, the scientific mainstream has taken steps toward the same conclusion. In 2013, a scientific study suggested that the chondrules were created by lightning within a theoretical protoplanetary disk. A Space.com report on the study stated, rocks melted in the early solar system after electrical currents spiked through the cloud of dust circling around the young sun. Some have suggested a similar process for comets, after the astonishing discovery of complex crystalline structures in dust particles from the comet Wild 2 in NASA's 2004
All these
Stardust
amazing
mission.
answers to
The mission's principal investigator,
these
Donald
so-called
Brownlee, said of
mysteries.
the discovery, "In the coldest part of the solar system, we have found samples that formed at extremely hot temperatures. When these minerals formed, they were either red hot or white hot grains, and yet they were collected in a comet, the Siberia of the solar system." A few have suggested that a, quote, transient heating event, such as shocks or indeed lightning in the outer regions of the protoplanetary disk, may have created the anomalous minerals in the Wild 2 dust samples. As explained in several previous Space News episodes, many recent discoveries emphasize how little scientists today really understand about lightning. The study of lightning illuminates the electrical connectedness between the Earth and the Sun, and it may also provide a window to past events that forever changed our world and remain a puzzle yet to be resolved. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
This is a good one.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The electric universe theory has laid the foundations for an entirely new understanding of planetary geology. For decades, experimentalists using electrical discharges have reproduced many familiar geological features, including types of crater forms that have long proved puzzling to standard geology. These experiments may provide clues to past events that the scientific mainstream has never entertained. High-energy electrical discharges at an interplanetary scale. Is it possible to integrate these new possibilities into a geology that also includes standard geological processes? In this episode, our guest Barry Setterfield, the astronomer at the New Hope Observatory in Grants Pass, Oregon, outlines a number of guidelines for assessing whether craters on planets, moons, and other bodies were created by impacts or by electrical discharge machining.
Okay, well, I was teaching astronomy at the time, and the issue of the origin of craters on astronomical objects of all sizes had come up, and we needed to resolve this issue with the students. For example, in the days before the Apollo moon landings, and even for some time after, there's a strong body of opinion which held that all such craters were the result of volcanism, and that idea died slowly. It was replaced by the idea that all craters are the result of impact. But then the results of electrical experiments became available, which solved problems that neither impact nor volcanism could. And I needed to do some cratering experiments to distinguish between the various types of craters, and then present these results to my students. Volcanism usually has craters at the tops of mountains. Unlike the moon and planets, the crater bottoms there go below the level of the surrounding plains. The volcanic craters that look like those on the moon are called calderas, but the calderas are only circular and at ground level if the collapse to a depression follows the first major volcanic outburst, and that's rather rare. The basic rule of thumb is that the rim material of lunar craters will approximately fill the pit. This is not usually the case of volcanic calderas, which have a different profile. However, it is the case with these other two methods. Now, Venus is covered with 1,600 volcanoes, mainly the shield type of volcano, which is similar to those in Hawaii, but they're more broad and flat. Radar surveys also show that Venus has about 1,000 craters, similar to the Moon and Mercury and Mars.
Yeah.
And these have a different character, and so they're formed by different processes. In addition, the proliferation of craters on very small asteroids and dwarf planets rules out volcanism as being the origin for those craters. You can't have a volcanic hot magma centered to such a small body. It doesn't work. So there are features of both impact-based and electrically based crater formation that correspond with what we see on objects in our solar system. Both methods of crater formation describe some, but not all of the features that we observe. From the experimental analyses that I have done, it seems that we have a mix of both electrical and impact-based craters. And these experiments seem to allow us to determine whether or not a particular crater may have formed by impact or by electrical discharge machining, EDM. Craters can be formed by the impact of some solid body, such as an asteroid or a meteorite, and as that body hits a planetary surface, its velocity can range up to 45 miles per second, which is pretty fast. This can be simulated in a lab experimentally. Since real impacts will smash any material from soft pumice to alloy steel, the material that we use in the lab should have no tensile strength. Now, there is such material, and it's dust. And for practical reasons, we use cement dust. It comes in uniform quality. And so we have a layer of cement dust about 6 inches thick in a large box or a pan. And the meteorite is then a spoonful of slightly compressed cement dust dropped from a height of about 4 feet. The resulting craters have a striking resemblance to lunar craters generally. In the case of an actual impact, as the impactor penetrates the surface, it pushes ahead of it an increasingly large plug of matter that becomes intensely hot and under high pressure. Eventually, the pressures involved reach something like 200,000 atmosphere, and this stops the plug of intensely hot material, and then a massive explosion occurs. It doesn't matter what direction the meteorite comes from, the focus of the explosion forms a circular crater around that. The pressures involved form what is called shock quartz in the plug, which can't be formed by volcanic processes. As the crater forms, the horizontal strata at the rim of the crater becomes upturned and folded back on itself by the explosion. So the strata will actually fold back in a reverse order like a mirror image. These mirror image strata sit beneath the debris layer near the rim and is an expected feature of many impact craters. The impact craters can exhibit rays made up of powdered material thrown out from the explosion center. These rays are bilaterally symmetrical, mirror image that is, not radially symmetrical, and this is typical of explosion pits on Earth. The best example on the moon of the ray is the ray system of the crater Tycho. Impact craters often have radial ridges of material excavated from the explosion as well. And in addition, there'll be central peaks formed for craters within a specific size range. But that range depends on the gravitational pull of the planet or the moon that's formed on. Lesser gravity means larger craters for explosions of the same energy. Craters from impact will often have terraced walls as the ring wall slumps along the tangential fault lines set up by the explosion. There's also a set of radial fault lines going away from the crater center for the same reason. The craters, the terraces, the central peaks, the rays, and the radiating ridges can be reproduced in the lab experiment. So can multiple and overlapping craters, especially if the impacting body breaks up just before hitting, either in reality or in the lab. And in fact, if you use a plaster of Paris meteorite instead of a cement dust meteorite, you can see what happens to the meteorite as it impacts. And you find the meteorite fragments become concentrated under the rim of the crater.
In contrast to the characteristic features of impacts, what are some of the telltale signs that a crater was most likely formed by the process called electrical discharge machining?
Craters is formed by this process, electric discharge machining, or EDM, happen when there's a persistent electric current in the lightning light discharge, which excavates or machines out a circular pit. This has been investigated in detail by lab experiments at, for example, the Vemsat laboratories by C.J. Ransom and others. Although electric discharge machining, EDM, can produce craters that are bowl-shaped, many craters formed by EDM processes have vertical walls and almost flat floors. This is rather like a number of craters on Mercury and Mars. There may or may not be a rim of debris around the EDM crater pit, depending on local conditions. And because of the behavior of electric currents, multiple or overlapping craters can often occur. So can the scalloping of the crater edges or the wall. Where the current is high, and this is something important too that I noted, where the current is high, the ground in the region around the crater or craters is often discolored, and you can see this in some locations on Mars. One of the diagnostic features of EDM craters is that they can have a series of ejector blankets on top of each other that looks like a series of fluid flows. You get the one blanket on top of the other, and you get lopes and scarps and so on. This happens as one layer of dust and debris from a machining gets added on top of another over a relatively short time. However, it's impossible for this sort of blanket to be formed by more or less instantaneous explosions from an impact, as several different explosions would be needed in a series of events to form the different blankets to a single crater. Instead of radial ridges, the electric currents involved can form a radial system of grooves around the crater. These are a form of Lichtenberg figure machined out by the electric arc. In addition, the dynamics of the process allow for central peaks in craters of any size. You can't do that for impact craters, as well as circular rings in place of the central peak. Where you have circular rings in place of a central peak, these are called peaked rings, and they usually occur in craters with flat floors and vertical walls, and so they probably have an EDM origin rather than impact. For example, the crater Meade on Venus consists of almost vertical walls, several concentric rings, and a flat floor, and is about 175 miles across. This strongly suggests an EDM origin. Some small crater chains can be formed by impact, but the extensive systems on the Moon and Mars rules out any impact origin. In addition, many craters in the chains are connected by flat-floored grooves. The craters themselves usually have flat floors, and some of these small craters even have central peaks. And so this is impossible to form by impact. These characteristics also eliminate volcanism and only leave EDM as their origin. Indeed, if such machining can produce this form of crater chain rather easily, and there are some excellent examples on Mars and the Moon which parallel the electrical experiments. So these crater chains are actually evidence of EDM.
We have noted the ability of electrical discharges to produce flat-floored craters. Does this mean that all flat-floored craters on planets and moons are electrical in nature?
No, probably not. For example, there are some flat-floored craters on the Moon which border the Great Plains, like Archimedes and Plato around the Mare Imbrium. When their walls are examined, there's evidence that flying debris from the formation of Imbrium itself, when the explosion happened, crashed through these walls. So these craters were there before that Great Plain formed. The material that now covers their floor has the same texture, color, and spectral composition as the material making up the Great Imbrium Plain. So it seems that this originally molten rock that formed the plain has penetrated these craters, filled up the depressions, and given them flat floors as a result. So we need to be discerning as we have a look at this issue.
In summary, we asked Barry Setterfield which features he feels are most reliably diagnostic for distinguishing impact craters from those unequivocally associated with electrical discharge machining.
Okay, if we start with impact craters, any or all of the following features will indicate impact has occurred. You've got your overturned rim layers or inverted strata on the rim. You've got a ray system and or radiating ridges. You have nickel-iron bodies embedded under the rim. You have shock quartz and or an associated iridium or osmiridium anomaly, and a concentration of mass, a mass con, as it's sometimes called, associated with it. Now for EDM, any or all of the following characteristics will determine if the crater has an electric origin. You've got your vertical walls and horizontal rim strata that are not mirror image. You've got an ejector blanket system of multiple layers, a central peak if the crater is outside the accepted size range for impact, and then you have a peaked ring system forming the appearance of concentric craters with flat floors and scalloping of crater walls. So all of these criteria would form the basis for determining which craters are formed by either process, unless, of course, new developments in both electric discharge machining or geology come to prove otherwise. In both electric discharge machining or geology, new developments forming the appearance of concentric.
1, 2, 3, 4, 5. Face. It's a hexagon right there.
Craters with flat floors and scalloping of crater walls. So all of these criteria would form the basis for determining which craters have formed by either process, unless, of course, new developments in both electric discharge machining or geology come to prove otherwise.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
So SAPPHIRE as an astrophysical laboratory. I've spoken several times about how we might use the SAPPHIRE chamber to explore solar physics, planetary physics, cometary physics. And here's a list of some of the areas that we are gearing up for. I'm not going to describe all of these because that would take several hours. Coronal mass ejections off the sun, coronal streamers, structures inside the corona that have peculiar properties, the electrochemistry of comets, how what kind of substances might be created if electrical forces are brought into cometary physics, temperatures in the corona of the sun, double layers. The exploration of double layers is just starting. It's so exciting. They're showing up everywhere you look. So we're in a beginning phase of double layer research now. Fast radio bursts, I haven't talked here about those, but another aspect of radio astronomy that's not very well explained. Ionization potential of elements, heliophilic boundary, ionophilic boundary. So that's about 30 or 40 years of research for the SAPPHIRE team. So hopefully we can get the ball rolling and then other people will join into the fun. Now, one of the main objections to our program is that suggestions that you can't really replicate these things in a box, right? That suns and planets are too big, the vacuum of space is too strong, you're not going to be able to get meaningful results by studying this in a laboratory. And that's a reasonable challenge. When faced with deciding if something is possible or not, I don't usually look to equations first. I usually look to experiments, or I find somebody that tried it to ask if it's possible. So you could say actually anything is theoretically impossible until someone actually does it. So the things that other people have worked on are highlighted in red. Those have already been worked on in laboratories outside of SAPPHIRE. There's probably other work that's been done also. If anybody knows any other labs that have done research in these other areas, by all means, contact me. We need all the input we can get. So SAPPHIRE is a tool. SAPPHIRE is a tool that we have to use with lots of other tools to understand how electricity manifests in the solar system. And to understand anything scientifically, there's usually a back and forth process that starts. Sometimes you look out into nature and see what nature's doing, and then you go back to your laboratory and you try to do the same thing. So that's kind of like from an outside in. But sometimes you do it the other way. You go to your laboratory, you observe phenomena, and then you go look for it outside in nature. So those are two very different directions for how one does science. And both directions are absolutely essential. That's how new paradigms come into being, is with both of those directions. Now, so far, the last several years when I've spoken, I've really only talked about from the outside in, that long list of phenomena that we're observing around us and trying to figure out, well, how can we replicate that in the lab? So today, I'm going to talk about the other direction. How do we take what we see in the lab and then go look for things out in the world around us? So what you're looking at here is a proposed shape for the electrical potential between the sun and the earth, actually between any star and any planet, between the sun and the earth. Now, you're not going to see this diagram in any astrophysical literature. The earth over here, the sun over there, a lot of space in between here, leaving the sun, covering all the great reaches of space to the Earth. And this blue line is a proposal, an idea, a sketch for how the electrical potential looks between a star and a planet. As one moves away from the planet, a very steep rise of a lot of voltage that's wavy, goes up in steps, then a little bit of a drop off, and then a slow rise over great distance back up to the star. Now the number I put on here, I realize I didn't take spherical geometry into account, so this number is probably going to be more than 600. It's probably going to be 1,200. Who knows? Just this is a sketch. So why am I saying this, that it should look this way? Well, it's an educated guess from the SAPPHIRE data. It's also based on about 100 years of plasma discharge experiments in laboratories. And this is also from me thinking about and digesting the work of Anthony Peratt, Ralph Jurgens, Wal Thornhill, Don Scott, etc. And so based upon all this data in the lab, I'm saying, let's go look for this. Let's go out and see if there's any data that supports it. So the first, here leaving the planet, that quick rise off of the planet, we actually do see that. There's plenty of data for that. It's called the fair weather potential. There's various explanations in the literature as to why that is there. Almost all of those explanations say that that big increase of voltage is caused by lightning on Earth, is the cause of that. And I'm starting to think it's probably the other way around, that if anything, lightning is trying to dissipate that voltage, because that voltage is part of a larger picture of a planet's relationship to its star. So the model's doing pretty good so far. What about the squiggles? Why did I put those in there? I put those in there because in the laboratory, a large electrical potential change in plasmas almost always happens in steps. It doesn't go smoothly, it doesn't go all at once, it almost always goes in steps. So I put steps in there because that's what one sees in the laboratory. Let's just say a little bit more about that to give you a flavor. Let's say I have two places in space. Point A is at a high voltage, point B is at a low voltage. Okay, and then there's going to be a connection between them. We're going to fill it with plasma or something, put something in between those two. So you might first guess that the voltage would do something like that, but you hardly ever see that in nature. What you see sometimes is something more like this. There often will be a really quick change and then not much after that. But a lot of the time, what nature does is something more like this, because achieving that change in voltage in steps. Here are some, you've seen some of these, some of the pictures from SAPPHIRE. These are steps in voltage. The chamber is, accommodating the difference between the center and the edge, accommodating that voltage change by putting it in steps. Okay, prior to drawing the graph that you saw, that blue line graph, I knew very little about the ionosphere. I still know hardly anything about the ionosphere. It's a very complicated structure on our Earth. But I thought, well, if my model is predicting there should be steps of voltage change, let's go look for it. Do I have any data that I can turn to that says, yes, this happens in steps? So this is a picture that's often published in geophysical texts. The surface of the Earth is down here. You're going up, leaving the Earth by going up that way. Everything we know, right, is right down here, basically. And I want you to look at this red wavy line to the right here. That is a graph of the free electron density as you go away from the Earth. And as you can see, it doesn't increase smoothly. It increases in steps. I read plenty of explanations for why the steps are there. Almost all of the explanations talk, again, about local causes, ignoring any kind of picture that would be placing the Earth in a larger environment where these would be expected. And one of the main attributes of most of the papers that describe it is how surprised everyone is by the steps. And then you have to go try to explain it because you're surprised by it. But you're only surprised when you have the wrong model. right? If your model is right, then you're not surprised by as many features. So coming back to this diagram, which I put in here for these steps because of phenomena I know in the lab, look out at nature, the amount of free charge is going up in steps. Now, is that exactly the same as what I'm describing, the ionosphere in the chambers? This is why we have to do the research, because no one's looking at this yet. So now we can have we have a model, we have a question, we can go back to data and explore it more. So let's keep going, right? So we did here. Now what about this? Why did I put that in there? Well, I put that in there, again, because of studying phenomena in the laboratory. Now let's go out and look at nature and see if around the Earth there's anything like that. Well, there are these really strange structures around the Earth called the Van Allen belts. I knew a little bit about them before working with this model. In their simplest form, they are a couple of layers of charge in close to the Earth, in a region that's dominated by positive charges, and then on the outside, regions that are dominated by negative charges. So on my blue drawing, I had a high point there. That would be right about here at where the Van Allen belt has the most positive charge. And then it dropped off. That would be out here where the Van Allen belt, where the negative charge starts to increase. So what I just said is not accepted by any astrophysical journal. If you call up the radiation belt storm probe people at Johns Hopkins, like I did, and you ask them about this, I was told very calmly but insistently that, well, there can't be any charge separations in space, so no, you can't have positive and negative just separate like that in the Van Allen belts. Okay, thank you. Oh, I went back to the data is all published, which is awesome. All the data from these satellites, if you want to analyze data, it's great. And so I went back to the raw data from the satellites with my question, because I was like, well, I still think the model might be right? And so there's satellites flying through these belts. They go out, and then they come in, and they go out, going into the inner belt, back out to the outer belt. Here is some data, sample data. There's about 7 hours on the horizontal axis here, about 7 hours of time passes by. The satellite is outside of the Van Allen belt, and then it comes inside into the inner belt, and then leaves the outer belt. So this interesting part here is when it's going from the outer belt into the inner one, and then back out. So this is electric field. Okay, electric field is not the same as electric potential. My plot has electric potential, right? But the two are connected. If you know the field, you can determine the potential and vice versa. An equation that connects them is this. It says that if you know the electric field everywhere or along a path, and then you multiply that electric field by every point in your path as you're traveling, and you add all that up, that'll give you the potential, the amount of potential change, which would get back to the plot that I drew. So I took the raw data of the electric field measurements from the satellite, integrated it through the orbit, and get a plot kind of like this. So as I'm coming into the Van Allen belt from far away, there's this interesting structure, don't know what that is, but there's an enormous change, increase in potential as you go into the inner belt. And this changes thousands of volts. So that pretty much says to me that the inner belt is at a much higher potential than the outer belt, which means that you have to have separated charges to maintain that. So coming back to the diagram. Lasso. Yeah. Again, this, as you come towards the Earth, from the outer belt going into the inner belt, a rise up. That's going to be the highest point locally of the potential right there. So again, I want to recap, try to make this clear. what I just talked through is pretty amazing, okay? I sketched out a proposed graph for what we would see if we went out and looked at any data available for us. And I got this graph by looking at data in the laboratory, okay, and listening to people like Wall and Don and others. I didn't create this graph initially by looking at any NASA data. I didn't create it by reading any publications about electrical environment or between planets and stars, okay? And I took that graph and then I went to the literature and said, well, does the literature support my model? And I just talked through the ways in which it does. So we should keep going, right? Okay, what about this slow rise here? And anything we can find out about that? So if you stay up late nights reading instead of resting, then you might come across some amazing papers in the late 90s and early 2000s by Mangini and Salem. And they used data from the wind satellites, which had a very high time resolution for measuring electric fields. And they analyzed their data. So the wind satellite sits on my diagram somewhere about here. It's between the Earth and the sun, I mean, in distance-wise, but it's away from the Earth. It's away from the immediate environment of the Earth. It's somewhere out in this area. And analyzing their data, they found that there is a continuous stream of double layers, electric double layers, coming from the sun outward, all direction. Well, the satellite's only here, streaming past the satellite, traveling double layers. So to give you an image of what that might mean, these double layers are little changes in potential, electrical potential, and they're streaming out from the sun. So you could imagine maybe a stream out on the East Coast. We have these mountain streams that they don't go down one big fall like a Niagara, right? They go down rock by rock by rock by rock, little changes in height of the water. So a picture of something more like that, if you're standing on the Earth looking at the sun, there's this stream of little increases in potential going all the way back to the sun. And if you add all those up, as Mangini and Salem do, they get 600 volts difference between the Earth and the sun. All those little increases, 600. They didn't, I found out not too long ago, they didn't take spherical geometry into account for adding them up. So there will be more of an increase as you get closer to the sun, just for geometric reasons. So again, this is pretty good stuff. This again was my picture here was drawn from lab data. Go find someone who's been measuring this stuff. Yeah, they have very much the same scope. So of course I put together data from a lot of different groups, a lot of different, people consider themselves geophysicists who are studying this. People only know the Van Allen belts who are studying this, etc. But they can be, all that can be brought together if you have the right model. Well, is there anything else we could predict? Well, it'll give, something like this can give directions for looking at connections between structures that we know about. So these layers in the ionosphere, those, remember that red wavy line, quite variable. They're always changing. They're never staying the same, okay? Well, we should start looking at how they're changing relative to what the Van Allen belts are doing, because these changes have to be linked. And we can look and see what kind of changes are happening in this stream coming from the sun. How is that affecting things? That's one direction we can go with this. And then what about what close to the sun there, right? So I was thinking all about that, but Don answered all our questions the other day. So you can ask him about what's happening right there. That's really it. That's my installment for this year. Thank you very much. I want to thank everybody who supported the Sapphire project. Very exciting stuff. Thank you.
Why don't you begin by telling us about your findings? And the first question I'd like to ask is, did you encounter any surprises in your research?
Oh, I did in fact experience
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The following presentation is an adaptation of the Stephen Smith Picture of the Day article, Most Atypical. A link to the article can be found in the description box of this video. According to a recent press release, Galaxy NGC 1222 is a, quote, peculiar example of a lenticular galaxy. It is peculiar because lenticular galaxies are supposed to have used up the material available for new stars to form. NGC 1222, on the other hand, is described as a starburst galaxy, since new stars are said to be forming at a surprising rate. Astronomers use high-frequency light from their active zones to identify star-forming regions. Extreme ultraviolet and X-rays radiate from so-called cosmic cocoons. The best examples are illustrated by one of the most iconic images in modern astrophotography, the pillars of creation in the Eagle Nebula. We are told that the unusual activity in a galaxy whose fecundity should be long past is because NGC 1222 is, quote, in the process of swallowing up two much smaller dwarf galaxies, bringing in fresh supplies of gas. Consensus opinions suggest that shock waves from so-called stellar winds generated by supernovae ram through star-forming regions, causing the wispy dust and gas to compress along the shock front, which supposedly jumpstarts star formation. How stellar winds, quote, blow through space until they encounter dusty clouds is not known. Another problem associated with star formation is that shock-heated gases should dissipate from increased molecular movement, not collapse. To say that gas can be heated until it emits X-rays that, quote, blow like a wind indicates a serious lapse. Molecules of gas cannot remain intact at million-degree temperatures because electrons are stripped from the atomic nuclei, causing them to become ionized. Instead of hot gas, the galactic surge should be referred to by its proper name, plasma. The electric star theory resolves many of the distorted opinions that arise from misunderstanding the role of plasma and electric fields in space. Rather than kinetic activity, the radiant emanations from NGC 1222 are due to electric charge flow. Electric discharges in a plasma could create double layers, or sheaths, along the current axis. Positive charge builds up on one side, and negative charge on the other. An electric field develops between the sides. Electric charge flows along the sheaths. In plasma, the currents pinch into filaments. The filaments attract each other. But rather than merging, they spiral around, gradually pinching down into arc mode discharges. As the Hubble announcement states, we can clearly see dark filaments of dust and bright filaments of gas. In an electric universe, stars give birth electrically from their charged interiors. There is no intensely hot core, radiating energy from thousands of kilometers deep inside. Instead, heavy elements are synthesized in the exterior plasma discharges and then precipitate into the star's interior like a rain of metal atoms. Electric forces acting on a star might offset its internal positive charge. If that happens, the positive charges will repel each other and accelerate away from the center of the star, resulting in an expulsion disk composed of the star's ionized interior. When plasma moves through a dust or gas, the cloud becomes ionized and electric charge flows. The currents generate magnetic fields that confine themselves into coherent filaments known as Birkeland currents. The charged particles that compose the currents spiral along the magnetic fields, appearing as electrical vortices. The forces between these spinning Birkeland currents pull them close together and wind them around each other. The three radiant regions in NGC 1222 are examples of Z-pinches in those filaments, comprising thousands of stars. Retired professor of electrical engineering, Dr. Donald Scott, author of The Electric Sky, wrote, "Plasma phenomena are scalable. Their electrical and physical properties remain the same, independent of the size of the plasma. In a laboratory plasma, of course, things happen much more quickly than on the galactic scales, but the phenomena are identical. They obey the same laws of physics. In other words, We can make accurate models of cosmic scale plasma behavior in the lab and generate effects that mimic those observed in space. It has been demonstrated that plasma phenomena can be scaled to 14 orders of magnitude. Electric currents flowing in plasmas produce most of the observed astronomical phenomena that remain inexplicable if we assume gravity and magnetism to be the only forces at work. Such is the case with all starburst galaxies. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. New observations are again challenging astronomers' ideas about the so-called volcanoes on Jupiter's moon, Io. For nearly 40 years, astronomers have told us that Io is the most volcanically active body in the solar system. In 1979, NASA's Voyager spacecraft offered scientists on Earth their first glimpse of mysterious structures jetting hundreds of kilometers above the moon's surface, a phenomenon astronomers interpreted as volcanic plumes. But that same year, the world-renowned astrophysicist Thomas Gold proposed that the locations of the so-called volcanoes were instead the sites of powerful electrical discharges. 8 years later, in 1987, plasma scientist Anthony Peratt and co-author Alex Dessler published the paper Filamentation of Volcanic Plumes on the Jovian satellite Io. Peratt and Dessler argued that the filamentation and cross-sectional shape of the plumes are, quote, consistent with theories developed from laboratory observation. Nevertheless, despite the contributions of Gold, Peratt, and Dessler, planetary scientists have held to the theory that Io's mysterious plumes are the product of volcanism, which is caused by Jupiter gravitationally squeezing the moon. But the problems with this theory have only continued to grow with better images and data from the Jovian system. NASA scientists have acknowledged their struggle to explain the plume's structure as volcanic in nature. Concerning the so-called volcano Vashtar, they state that the knots and filaments that allow us to track the plume's motions are still mysterious. In recent years, the tidal heating model applied to Io's, quote, volcanoes has been directly falsified by additional discoveries. In 2013, a geologic survey found that the locations of the plumes were incompatible with the predictions of the tidal heating model. And now, scientists observing the so-called plume of the volcano Loki have encountered a new mystery. A new scientist report on the observations states, over decades of study, observers have noticed a pattern. About every 540 days, a wave of brightness starts at one end of the lake of lava and pivots anti-clockwise like a windshield wiper. That front of warmer lava moves about 1 kilometer per day until the whole lake glows hot. Then the surface of Loki cools until the process starts again. But in 2002, right when we thought we had Loki pegged, those phases stopped. Then in 2009, according to recent work by Catherine DeClear at the University of California, Berkeley, they started again, but are now moving clockwise. Appropriate behavior for a feature named after the Norse trickster god. However, anomalous movements of Io's so-called volcanic plumes is not a new problem for astronomers. When the Galileo probe arrived in the Jovian system in 1996, it revealed that the plume of the so-called volcano Prometheus had moved more than 80 kilometers since it was first imaged by the Voyager probe. This fulfilled one of several predictions that physicist and electric universe proponent Wal Thornhill had made prior to the Galileo mission. Thornhill also predicted that the so-called vents of the volcanic plumes would be much hotter than lava, and that the plumes are in fact the jets of moving cathode arcs eroding the periphery of the dark areas that planetary geologists had been calling lava lakes. According to Thornhill, these so-called lava lakes are the solid dark surface of Io beneath the, quote, snow that has been deposited by continuous discharge activity. Therefore, the, quote, lava lakes would not reveal the expected heat of a recent lava flow. Each of these predictions received stunning confirmation. Io's volcanic hotspots were not only hotter than any lava on Earth, but were too hot to be measured by Galileo's instruments. Also, as predicted by Thornhill, The discharging was found to be focused on the edges of the so-called lava lakes, though the rest of these dark fields are comparatively cool. In fact, the expected volcanic vents could not be found, inspiring further astonishment among mission scientists. The quote, volcanic plumes emit ultraviolet light, something inconceivable under normal conditions of volcanic venting. But ultraviolet light is, of course, characteristic of an electric arc. Space scientists have come to depend on Io's volcanoes to account for the extraordinary electrical activity witnessed in Jupiter's atmosphere. Many claim that charged particles from Io's volcanoes are responsible for the Jovian auroras, which are 1,000 times more intense than anything seen on Earth. In this scenario, the profuse electrical activity at Jupiter's poles, approximately 10 million volts, is generated mechanically by the planet's spin. Ions from the quote volcanoes on Io are thought to travel to the planet's poles, then interact with the magnetic spin-generated electricity to create an extraordinary charge exchange, producing the auroras. The following NASA statement, which quotes investigator Randy Gladstone, reads, "The polar electric fields grab any charged particles they can find and slam them into the atmosphere. Particles for slamming can come from the sun, but Jupiter has another, more abundant source nearby, the volcanic moon Io, which spews oxygen and sulfur ions into Jupiter's spinning magnetic field. Somehow, these ions make their way to Jupiter's poles, where electric fields send them hurtling toward the planet below. Upon entering the atmosphere, their electrons are first stripped away by molecules they run into, but as they slow down, they start grabbing electrons back. The charge exchange reaction produces intense X-ray auroras. This rationale arises from the assumption that Jupiter itself has no net charge. But since it is behaving like a charged body, the scientists look to localized, mechanically induced charge separation, as if an island in space, through some internal process, can acquire and dissipate electric charge. From the electric universe perspective, what is actually occurring is an electrical connection between the Sun, Jupiter, and its moons. In recent years, discoveries have only supported this view. When scientists discovered the most prominent auroral trail, or footprint of Io in the Jovian atmosphere, they assumed it must be an effect of charge separation generated by Io's volcanoes. However, this theory was undermined in 2005, when Hubble images of the Jovian aurora revealed a similar electrical footprint imprinted by the moon Europa with its own swirling plasma tail. A research team wrote of this discovery. Europa is not thought to be volcanic, so what could produce the electrical current that zips along and eventually gives rise to Europa's auroral footprint? NASA investigators also found that the electrical exchange does not stop with Europa and also includes the moon Ganymede. As reported on this series, in recent years, space scientists have slowly edged closer to recognizing significant electrical discharge activity on planets and moons. It's now known that once a month, when the Earth's magnetotail passes over the moon, the result is electrostatic dust storms and electrical discharges. And in the past year, scientists reported that a coronal mass ejection struck the planet Mars immediately before mysterious plumes were seen jetting hundreds of kilometers into the planet's upper atmosphere, a complete surprise to planetary scientists. The purely gravitational processes that astronomers still prefer have failed to explain Io's so-called volcanoes. But today, the basis is clear for scientists to consider an alternative explanation in our electric universe. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Well, it's my great pleasure to introduce Wal Thornhill as the 2011 John Chappell Memorial Lecturer. Wal is a guru who knows his stuff and wears it lightly. That second bit is the rarity and the key. He has a Buddhist calmness and sense of timing. He responds to questions in the most succinct and helpful way. One wonders how any sort of universe, let alone an electric one, would function without a chap like him to turn to for solutions. It is that reassuring calmness that goes halfway to setting oneself up to find answers on one's own.
How could the artificially orchestrated energy crisis if everybody knew this shit?
His web articles are usually reactions to mainstream press releases, salted with some occasionally un-Buddhist animus, but they are never reactionary. Rather, we keep seeing the illumination of phenomena that are anomalous in light of conventional cosmology through the light of a paradigm replete with scalable manifestations. As Wall says, there is nothing more powerful than a paradigm. The electric universe extends plasma cosmology and views all stars as electric discharge phenomena. Here is Walt Thornhill on stars in an electric universe.
Thank you, A.P. David, for that marvelous introduction. And thank you to the NPA for giving me the honour of being able to present this particular lecture. I'd also like, when I'm giving thanks, to give thanks to the Thunderbolts team and all of those people from that team who've travelled considerable distances as well. And also to Dave Talbot for organising some of my fare here. Stars in an Electric Universe. This was to be the title of my second paper. However, I sent it first, and somehow or another it ended up as this memorial lecture. I had intended instead to speak about the natural philosophy of the electric universe, because in my opinion, it is a return to natural philosophy, and I see myself more as a natural philosopher than anything else. So I've got a little sprinkling of the natural philosophy as an envelope around this particular topic, stars in an electric universe. I particularly like this little cartoon. You'll notice the alien is walking back to his partner in this flying saucer, having spoken to an earthling, saying, "You won't believe the cosmology they've come up with." And that's my position. It is just another miraculous, unscientific creation story. It needs magic to begin and also to maintain the narrative. It has its sacrosanct heroes and a god, of course a mathematician, because it's been invented by mathematicians. It is based on a firm belief that the universe is expanding, because the evidence is already in that that's not the case. It denies evidence that can't be woven into the myth, and this is typical of any religion. In fact, Halton compared modern cosmology with the medieval church. I think we've suffered through the last century the demise of physics. I've recently come to the position that Stephen Hawking was right. Philosophy is dead. Ever since Kant claimed that the world we observe is all in the mind. Because following Kant and Einstein, modern physics has followed that same path, and it's also dead but won't lie down. I've recently read this book by David Harriman, I think his name is, called The Logical Leap, and it's about induction in physics. And he says, the only means of knowledge is reasoning from observed facts, and that's been the story for me. The senses provide our only direct contact with reality. He goes on to say that induction is much more difficult and controversial than deduction, and why it is not reducible to the formalism of symbols, and that's particularly true on the path that I've taken. Deduction takes for granted the process of conceptualization. Induction is the conceptualization process itself in action. David Harriman goes on to say that a conceptual consciousness is an integrating mechanism, and its product, knowledge, is an interconnected system, not a heap of propositions, which is largely how science is at present. And here's the man who taught me. I came across his book before I entered university. I was inspired by the approach, the logical leaps that Velikovsky took. I had never seen before. When I got to university, I spent a lot of time in the sociology shelves at the university library, just picking books at random about myths and legends from around the world. And I found that the stories were understandable. They tended to leap off the page at me, and I could see how they related to what Velikovsky had shown in his work. I believed that he had made a case that needed to be answered. One of the things he did do as well was to throw down the gauntlet to astronomers by saying that electromagnetism was involved in the celestial mechanism. But this was ignored by astronomers who simply said his work disobeys Newton's laws and therefore we can ignore you. They never picked up the gauntlet. In my view, cosmology must be a coherent natural philosophy and there can be no exceptions. If there's an exception, there's a problem with your cosmology. At present, the Big Bang doesn't address any of the big issues, in my opinion. I consider it a hopeless cosmology. It must provide insights into every discipline, including life itself and the human condition. And I think this is extremely important and something that Velikovsky felt also was important for our long-term survival. However, modern specialised science is a hostile environment for such a quest. Now, we do have an alternative cosmology that is accepted by the IEEE, the largest professional organisation in the world. It is based on the work of several Nobel Prize winners over the last century, has many successful predictions to its name, and also challenges the Big Bang. This is why astronomers ignore it. However, it doesn't handle unsolved problems in basic, particle, and stellar physics. And this is the area that the electric universe tries to address. It tries to tackle these fundamental problems, and in doing so offers a breakthrough in understanding of ourselves and our place in the universe. The electric universe, I believe, is an attempt at a convergent interdisciplinary cosmology. And the first thing to do is to get rid of some of the perpetrators of the demise of physics. In my view, science left the path of reason and objectivity in the early 1900s, and I'm sure I won't get much argument from the audience, having sat through very many very interesting talks at this conference. Einstein and his proponents bequeathed us, in my view, a disconnected, incoherent universe that simply cannot function or give rise to life. And this is why so much magic has had to be invoked to try and make the theory fit the facts. And if the facts don't fit the theory, you can ignore them. Don Hobson, who I believe is a member of the NPA, has said everyone who takes relativity seriously believes in the reality of at least one direction in which one cannot point. And I thought that was a very succinct way of putting it. I also believe that E equals mc squared, whether you attribute it to Einstein or anyone else, is the best known and most misunderstood equation in science. And I think this is a fundamental thing. In my view, the real meaning of E equals mc squared is that energy, mass, and the speed of light are all properties of matter. Electromagnetic energy, in my view, is stored in the orbital substructure of subatomic particles and manifests as their mass. The orbital substructure picture was given to me by Ralph Sansbury back in about 1981. Therefore, the mass of the particle is a measure of how much energy is absorbed in deformation of the particle instead of its acceleration. This is an alternative way of looking at the particle accelerating experiments. Are you having trouble hearing me? It's an Australian shirt.
It's upside down. His button's upside down.
So. Okay, now I can turn around. That's better. And this means also that energy requires the presence of matter. There is no such thing as pure energy or dark energy. And we can't say anything about the beginning of the universe because we don't know what matter is or how it can be formed. And this is just one of the principles of physics. There is no creation or annihilation of matter. So we try to conform to the principles as well of physics. Therefore, electromagnetic radiation requires the presence of matter. It cannot go through a total vacuum. In other words, the ether. And back in the 1970s, at the time that I met Velikovsky, there was Dr. Horace Dudley who proposed that the ether was comprised of neutrinos. It was a very intriguing idea, And when I came across Ralph Sansbury's view of particles having internal structure, it occurred to me that this particular idea answers a number of other questions, but I'll come to that later. The speed of light can be seen as a measure of the inertial response of subatomic particles to
a particle physics explanation, which is incorrect. That's why you can't, seem to put that together. Everything is fields, and that understanding will come later.
Varying near instantaneous electric force. This would make it a characteristic of the material medium. Now, a near instantaneous electric force implies a universal time, which I think also fits with many of the talks that I've heard here. And quantum energy transfers, a measure of the fact that all subatomic particles are comprised of smaller orbiting systems, and they must have a resonant structure. Newtonian gravity. This was the ex cathedra statement that was thrown at Velikovsky. It disobeys Newton's law. But what do we understand about Newton's law? Newton's law of gravity is instantaneous. It doesn't involve time. However, big G is a dimensional constant including mass. But mass is a variable, a measure of electromagnetic energy stored within that matter. So G can vary with the electrical stress in a body. Now this is significant when you think that big G is the least well-established constant in the physics textbooks. We do have evidence that Earth's gravity was much less in the past. The scaling of muscle and bone strength show that dinosaurs could not have raised their bodies off the ground in today's gravity. And this article here shows that the birds couldn't have flown either, those huge pterodactyls with their wingspan of a small aircraft. For them to move about, it's been calculated that Earth's gravity needed to be about 1/3 of today's. So therefore, the global extinction of the dinosaurs required something far more than just a simple impact. In other words, we do not understand gravity, the basis of Big Bang cosmology. We need new concepts. As David Harriman says in his book, just as valid concepts can propel science forward, invalid concepts can stop it. And I think we've been stopped for the last century. These are statements from astronomers. Charge separation in space is impossible. And I remember the kind of argument that I got at university, and that is, you calculate the amount of energy required to separate all of the positive charges and the negative charges in a teaspoon of salt, and it comes out at such a phenomenal figure that you just dismiss the idea that charge separation can occur in space. And of course, there's electricity in space, but it doesn't do anything. I did the postgraduate astrophysics course in London when I was working there, and I went up to the lecturer in plasma physics, the plasma physics semester, at the end of the semester and said, when do we do anything to do with electrical currents and electrical discharges in plasma? He said, oh, we don't do that. We come to Hans Alfvén, who's the father of plasma cosmology. To Alfvén, the Big Bang was a fable devised to explain creation, so he saw through it. And Fred Whipple said, Alfvén's theory must be mastered if further progress is to be made in understanding the universe. But Alfvén himself, despite winning a Nobel Prize, was marginalised. His successful predictions did not lead other scientists to adopt his program, but only to accept the existence of the predicted phenomena. What kind of science is that? Yeah. This is by Stephen Brush, who published this in the one of the IEEE plasma journals. Plasma cosmology and the electric universe can inspire, in my opinion, a scientific revolution of unparalleled scope. We see on the left there a planetary nebula and a plasma discharge tube, just as an example of the similarities. And they hinge on one simple question in both cases, plasma cosmology and the electric universe: does electricity play a role in the universe? The electric universe cosmology, a guiding principle of this is convergence of all human knowledge. This is why I've been associated with David Talbot and the comparative mythologists, because that extends our knowledge right back into prehistory. When you think about the short time that we've been observing the skies with modern instruments, it's a very narrow view of the history of the skies.
We do not want merely a modern consensus in one single specialized field. What is plasma? Moving plasma generates electric currents and forms current sheets, filaments, and bubbles. It produces radiation over large parts of the electromagnetic spectrum, and this makes radio astronomy extremely important in the future. There's already sufficient information to be able to overturn, in my opinion, all of the nonsense about the Big Bang available from radio astronomical observations. Interestingly, plasma behavior is extremely complex, far more than I ever imagined. As I say here, the flow of electricity through plasma can cause glows, arcs, jets, filaments, beads, bubbles, kinks, sausages, tornadoes, and explosions. That's a pretty fair range of phenomena to be going on with a single mechanism. It's just as we see in the lab, and as it turns out, it's just as we see in deep space. Of course, this has been mentioned, the electric force is 10 to the 39 or 10 to the 40 times stronger than gravity. And one of the scientists who was involved with the Velikovskian story early in the piece, Dr. Earl Milton, wrote an article called Gravitational Force is Zero, and he used this little example at the bottom. Gravitational force divided by the electric force is 10 to the minus 39, which is as good as zero as you can get. So we cannot ignore the electric force in the universe. In a plasma universe, we have to ask what physics lies behind these wonderfully mysterious objects that shine in deep space. All these glorious photographs we get from space are being viewed and interpreted by people who have no experience in plasma physics. It's obvious that energy has been supplied to the thin gas in space so that some atoms become ionized and glow. Astronomers are restricted to explosions to deliver the energy to this ionized gas. And in some cases, the distance between the glowing envelope and the central object that's supposed to have exploded precludes the explosion being responsible for the energy that we see radiated by these spectacular planetary nebulae. So the plasma universe can be far more complex than we ever imagined, while the underlying principles are very simple. And this makes it amenable to examining concepts and matching them with observations. Plasma cosmology is the study of the electrical behavior of matter on all scales. That's from the atomic up to the galactic cluster. It's based on sound empirical principles and laboratory comparisons. It accepts a universe of unknown extent and age, which is the kind of thing which Halton Arp's work, I think, is suggested is the case. And it forms the backdrop of the electric universe. On the left, you see electrical discharges across the room of the Sandia Z machine, as they call it, which produces the most intensely concentrated electric discharge on the planet, man-made discharge. And it says for billionths of a second, it focuses about 80 times the entire world's output of electricity into a few cubic centimeters. And in that instant, we see the sorts of patterns which we see in deep space, and we see chiseled in rocks on the surrounding country, out in the surrounding countryside near Los Alamos. Christian Birkeland is one of the electric universe pioneers. He was a Nobel Prize nominee and a pioneer. He built a model electromagnetic Earth, his Torella experiment, to mimic an aurora. And a good book about his life is by Lucy Jago called The Northern Lights. It's a good read. The thing is that this Torella needs electric power to work. So the phenomena we see in his experiments has to be powered electrically externally. And this is important, of course. He wrote, "It seems to be a natural consequence of our points of view to assume that the whole of space is filled with electrons and flying electric ions of all kinds." He was rather prescient in his statements. There's more to come. These filamentary currents, which follow the magnetic field, the ambient magnetic field, which you can see here, are named after him. And it is the force-free means of transferring electrical power from one part of the universe to the other. The current filaments naturally form double helix or twisted pairs at every scale, from the laboratory to galaxies. And that's due in part to the difference in mass of the positively charged
particles that carry the current, and the negative, of course, the electrons that carry the current. It's interesting how these small differences here and there account for the complexity. So in deep space, we have cosmic power lines. The electrical power transmission lines in space are usually in dark discharge mode. In other words, they can't be seen. However, they can be traced by radio astronomers. That's why I say radio astronomy is extremely important. Birkeland currents are to be found on all scales, from the lab to the galactic cluster, and can be detected by their magnetic fields. So like birds on a power line, we're unaware of the energy coursing past us so far. This is an experiment I did in Melbourne at the laboratories of the major telecommunications carrier with high voltage equipment. That red insulation is wrapped around a very heavy gauge copper pipe, and it's connected via this rod, which I'll show you in action in a moment. It's going to close the circuit between those two conducting balls you can see there. And this is the result. It's compressed in both radially and longitudinally. It came down very hot. I had to toss it around until it cooled. And here we see an example in space, the very same effect. We're looking down the barrel there of a planetary nebula.
Nice.
This is an example of the electromagnetic pinch. It's also called the Bennett pinch. And you'll see here three examples. One, the laboratory example, the Southern Crab Nebula in the centre, and supernova 1987A, which is one of my favourite objects, since it shows all of the phenomena we would expect from a plasma pinch effect in space, and suggests that supernovae have nothing to do with an internally generated explosion in a star. Alfvén had an article published in the Boston Globe, I think it was in the 60s, and it was under the heading of Alfvén's Electric Universe. But one of the important statements he made was important fields of research, for example, the treatment of the state in interstellar regions, including the formation of stars, are still based on a neglect of Bennett's discovery, that's the pinch effect, more than half a century ago. Present-day students in astrophysics hear nothing about it. He said that in 1986. Starbirth. One of the features of an intense lightning bolt is that the current can actually pinch off totally so that it forms bright beads or plasmoids. So bead lightning appears with a particularly powerful fork lightning. It looks like the lightning discharge channel is broken up into a string of glowing plasma beads. So last year there was a report from the Herschel Space Telescope, which is looking in infrared into the birthplaces of stars. And here's a quote from the paper. A view of an incredible network of filamentary structures and features indicating a chain of near-simultaneous star formation events glittering like strings of pearls deep in our galaxy. That is, in effect, bead lightning in an interstellar cloud. There was a subsequent paper which examined some of these filaments in more detail, and here's the quotes from that paper. The filaments are huge, stretching for tens of light years. And regardless of the length or density of the filament, the width is always roughly the same. That's like cloud-to-cloud lightning. But the explanation of the astronomers is that all of these kinks in that are caused by exploding stars. So I asked the question, where are these exploding stars? And shouldn't there be some sort of radial curvature associated with those filaments? Instead of that, it has the same kind of tortured path of lightning. And the stars form along those filaments. An important aspect of the formation of stars and of all condensed bodies in the universe is this effect that occurs in a Birkeland current filament, and that is that it scavenges very efficiently widely scattered material and draws it into the central axis of the Birkeland current filament. Now, the interesting thing is that in the standard model of the collapse of the protostar material, it's all radial, and astronomers have cooked up a story whereby the final collapse of all that material is adiabatic. In other words, there's no heat escape. Because the material here is distributed along that filament,
the coolest part of the matter here is along the axis. And the other very important aspect of Markland convection is that all of the cool, low ionization potential elements, which you can see there are carbon, sulfur, iron, silicon, and magnesium, all the things you need to make up a planetary core, are deposited along that filament at the axis. Of course, once you've got sufficient material along that axis, there is a tendency for it to break up into blobs or into stars. So this means that they must constitute the core matter of stars, not hydrogen. You'll notice that hydrogen and helium are on the outer rim of that Birkeland filament. So this destroys any idea that stars have hydrogen cores. Another thing that Hans Alfvén said was, by analogy with the magnetospheric circuit, we may expect the heliospheric circuit, that's the one of the sun, to have double layers. Now, double layers are a situation where a current is flowing through a plasma and the plasma encounters sufficient change in the density or the temperature or whatever, the plasmas on either side, it will form a double layer. A double layer has positive charge on one side, negative on the other, and it creates radio noise, it accelerates particles to cosmic ray energies, it can, and they are situated on the axis of these currents. Okay, so he said no one has yet tried to predict how far from the sun they should be located. So far, no one has cared to look for such objects. That was in 1986. So here's a prediction way back in the 80s. This is a picture of his circuit. Over here we have the yellow sun, and here are the polar axis currents, and you notice the double layers up here and down here symmetrically situated along the rotational axis. The circuit obviously has to be closed, so somehow out here you get this flow this way. This is looking at the electron flow in this particular case, because obviously protons flow from the sun in the opposite direction along here, we know that. Hans Alfvén took the traditional view that the sun is a thermonuclear bomb going off slowly, and therefore that it was the source of the current, and he called it a homopolar generator. We take the different view that the sun is being powered externally, and that this circuit is actually connected to the interstellar circuit. It's induced by the current that's flowing past the sun. So what do we find? This is a very recent report. They found local cosmic rays, and they can find no source for them. And they're situated in the polar regions, north and south. This is a picture of the ice cube neutrino detectors buried at the South Pole. And they were surprised to find these hotspots, they call them, 0.03 light years away from Earth, because they must be within that distance actually, because further out galactic magnetic fields should deflect the particles and smear them across the sky. So here we have evidence for another of Alfvén's predictions. Of course, no such sources are known to exist conventionally. I believe, this is my diagram, the electric sun has been confirmed, because last year we heard stories about these energetic neutral atoms which are entering the heliosphere. This is the heliosphere, the sun's this little speck in the middle, and the current that flows in the equatorial plane of the sun, it may not be equatorial actually, because these are aligned with the local magnetic field as you would expect from Birkeland currents. And here are the double layers that I've drawn in here, the cosmic ray accelerators. So the Earth orbiting in here will experience cosmic rays from here and from here, which is what's been found. This discovery of energetic neutral atoms in a ribbon around the sun, around the solar system at some unknown distance, was a complete and total surprise. There was no explanation for it. The other thing is that the particles come in from bright spots. Now, these columns here are actually a cylinder of Birkeland filaments. So you'll find bright spots where some of those Birkeland filaments are distributed around this cylinder. If you can imagine, that's a cylinder of electric current from the local interstellar Birkeland current. So, in my opinion, we have confirmation of the electric sun and its connection to the interstellar circuit. The actual method of inducing the currents in the heliosphere, of course, is yet to be determined. It's very important here that the sun's Z-pinch is aligned with the local galactic magnetic field. That's diagnostic of the fact that we are sitting in a cylinder of Birkeland currents, interstellar Birkeland currents. These energetic neutral atoms come from solar wind ions meeting the Z-pinch current cylinder. What you've got coming down these filaments is a beam of electrons. You've got a beam of protons and other ions coming out here. Where they meet, they combine to form the energetic neutral atoms. So evidence for the particle accelerating polar double layers is arriving, and something to keep an eye on in future reports. Here's an example of the Red Square Nebula, which is an amazing feature. It's 34 times closer than supernova 1987A, so we can see much more detail than we can in that distant supernova. You remember in the supernova, we had these ellipses arranged along the axis of the supernova. In this case, the pinch is intense. The star is in here, and this shows you the pinch. These fine filaments here, they call them a cone in the original paper, are crossed by these very distinct, very thin, bright layers here and here and here. These are the double layers. This is where they're actually visible. The astronomer said this is the best astrophysical laboratory yet discovered for studying the physics of generating the mysterious sharp polar ring systems like that around supernova 1987A. A system as complex and fascinating as this is bound to keep us guessing for years to come. Well, the answer's already in. The linear rungs or bars of the red square fit Alfvén's circuit diagram as polar double layers symmetrically situated along the Z-pinch filament some distance from the star's two poles. Their thinness and electrical excitation results in the enhanced glow and sharp definition of the rungs or bars. There can be no mechanical explanation for such a complex structure. Electric stars. They're nothing new. As Rens van der Sloot said in one of the early talks, in 1885, the English astronomer Sir William Huggins presented the Royal Society of London with his electrical model of the sun.
Look at that.
And he said, the grandest displays of terrestrial electric disturbance must be altogether insignificant in comparison with the electrical changes which must accompany the ceaseless and fearful activity of the photosphere. Surely there's not too much to say that our terrestrial experience of lightning and of aurorae fails to supply us with any adequate basis for the true conception of the electric forces in action on the sun. Of course, Charles Bruce, back in the 1940s, also felt from his much better observations of the sun that matched electric discharge phenomena and lightning phenomena. The standard solar model, this is the culprit. Arthur Eddington deduced the nuclear energy concept of stars. He based it on a number of premises, all of which were false, and yet he had the temerity to say it should not be too difficult to understand such a simple thing as a star. He used gravity and simple gas laws applicable on Earth but not in the solar plasma, which resulted in a simplistic model that took no account of the observed complexities of the sun. It is an impossible solar model because the coronal temperature is in the millions of degrees, the chromosphere is 10,000, photosphere 5,700, and the core requires a temperature of the order of 15 million degrees and an unreal density for hypothetical nuclear fusion. Even the nuclear fusion reactions cannot be tested. And in order to make it work, it involved quantum tunneling and all sorts of magical tricks to try and get a theory which would work. It was very clever, but is it real? It also needs a radiative zone unknown inside any other hot body. That had to be put in, of course, because you've got intense X-rays coming from a 15 million degree core, and somehow that had to be converted into just heat and light at the surface. Here's Ralph Jurgens. You've seen him before, some of you. He presented in the 70s, 1972, a gas discharge model of the sun. He wrote, the modern astrophysical concept that ascribes the sun's energy to thermonuclear reactions deep in the solar interior is contradicted by nearly every observable aspect of the sun. I was inspired when I read his article. He provided a detailed gas discharge model applicable to all stars, a single model for all stars. This is quite distinct from modern cosmology, which has a separate theory for every star. So electric stars, like the lights of a great city at night, stars are lit at great distances from where their power is being generated. Each star forms the focus of a Z-pinch in the current stream. An electric star, for stars like the sun, the current flows in dark mode, so we don't see the spectacular glow mode bipolar wiring harnesses of supernovae and planetary nebulae. But every star has this form in its current feed system. Then how do we look at the sun within the heliosphere? Because these plasma sheaths, or the heliosphere, protects what's inside from the electrical environment outside. Most of the voltage that drives the sun occurs out at that distant boundary. This is why the spacecraft that are traversing that region at present are suffering so many surprises, because nothing's behaving the way they expected. They thought it was just a collisional boundary. It's not. Most of the voltage that drives the sun occurs across that thin boundary, and the result is, as Ralph Jurgens suggested, it's the origin of most of the cosmic rays in our galaxy. Every star has this cosmic ray accelerator at the boundary of its heliosphere. It's called the virtual cathode, because if the sun forms the anode here, and it's just a coronal discharge into thin air, thin vacuum, there is a virtual cathode set up by the plasma. It's the boundary of the sun's electrical influence. It is the virtual cathode in the stellar corona discharge, and most of the sun's driving voltage appears across the plasma sheath. A very important point, because all of those who've, the pseudo-skeptics I call them, who attack this model, say, where are all the relativistic electrons streaming past the Earth? You know, we should see them. The point is, if you'll notice, that this here is the voltage gradient through most of the heliosphere. The only place where you'll see swift changes in that voltage gradient is at the virtual cathode. You'll notice the size of it here, and this little blip when you get into the corona. That's the thing that accelerates the particles in the corona and heats them to 20 million degrees. Solar electrical effects. The sun's surface is carpeted with complex magnetic fields. Only electricity can produce magnetic fields, therefore the sun must be understood in terms of electric circuits. Where are these circuits and what creates them? And what sustains them? Plasma physicists know that the movement of different types of plasma past one another will generate currents in the plasma. When you get back to first causes, we do not know. We don't even know the right questions to ask at this stage of our ignorance, I would suggest. Sunspots are an embarrassment in the thermonuclear model. They have powerful magnetic fields with the same polarity spots clumped together. Now, normally the same polarity magnetic fields push one another apart. However, the magnetic field here is a signature of the Birkeland currents piercing the photosphere. And the pinch effect means the magnetic field is very intense in sunspots. They are drawn together because parallel currents are tracked. It's as simple as that. Ampere's law. Their darkness, structure and behaviour have required great ingenuity in attempts to explain them, yet they remain mysterious. I asked the question, does this sunspot penumbra, this is where you can see edge on to the photosphere and look deeper into the atmosphere, or the ionosphere, I should say, of the sun. And I asked this question, does this sunspot penumbra look like turbulent boiling hot gas? And I would say not. It has structure, it has a motion which doesn't look like boiling material coming up from the interior of the sun. And why is the sunspot dark if the sun is hotter beneath? It should be blindingly bright, because we're trying to get that 15 million degrees energy out through this hole, which is looking deeper into the ionosphere of the sun. The simplest answer is that the sun is thousands of degrees cooler below. And remember I said stars are formed with cool cores? They're not formed with hot cores. They could never have any nuclear reactions in their core under those conditions. Here we come back to Birkeland. This man was amazing. He wrote, "It might be imagined that the interior of the sun formed a positive pole for enormous electric currents." So there's your electric sun. This assumption has the advantage of appearing to give a natural explanation of the movement of the sunspots in various latitudes. This experiment has been repeated back in the 60s, and depending on the current input, those spots move in latitude, which is exactly what we see. So the sunspot movement across the latitudes on the sun is a measure of the changing input to the power input to the sun. In this case, he wrote, the origin of the sunspots must be that the presumptive more or less insulating photospheric envelope was sometimes pierced by disruptive discharges. I couldn't believe it when I read that. Thus forming great electric arcs. I would say he was the first one to actually tell you what a sunspot is. And that was from his huge tomes called the Norwegian Aurora Polaris Expedition, published in 1902, 1903. What do we find today? This is the sun in ultraviolet light, and you can see that we have an equatorial view at the top and a polar view at the bottom. And it has a plasma torus about it. And this is exactly what Birkeland had found in his experiments, that you get a plasma torus. And it's a storage ring, it stores energy. When that energy gets to a certain level, a massive discharge will take place from that torus to the surface of the body, and it follows the magnetic field lines. In the extreme case, when there's too much energy in that ring, it may actually switch to a polar jet. Many stars have polar jets. I suggest that these long filaments in the penumbra are actually electrical tornadoes, thousands of kilometers long. They have bright edges, dark cores, and a twisted appearance. And there's a special effects fire here with a helicopter engine above, and fire is injected at the bottom. And you can see the bright edges here and the dark core. And you can see these filaments here. It's exactly what they've got. And bright lightning flecks the tops of the granules. These are the solar granules that we see covering the sun. So the sunspot cycle, you see the sun in X-rays, and it is a variable star. It almost winks out at solar minimum, and at solar maximum it is much brighter. And X-rays are a direct measure of electrical activity. The sun is connected to a galactic circuit which is subject to quasi-cyclical change, so that the origin of the sunspot cycle is beyond the solar system. It may be due to alphane waves and the Birkeland currents that feed the solar system, or it could be due to the actual motion and rotary motion of the Birkeland currents past the heliosphere. Seen in X-rays, the sun is a variable star, and yet the heat and light from the sun is constant to within 1/10 of 1%. An explanation is very important, for it explains why most bright stars shine steadily. And it's not like the 4th of July. An electric sun, this is something that Don Scott pointed out, because he's an electrical engineer and knows this stuff inside out. He set this voltage curve here across the photospheric tufts, those long filaments that we saw a moment ago, is that of a PNP transistor. In other words, this tufted sheath of our sun forms a barrier for protons escaping the sun, because those protons trying to escape the sun have to climb this barrier here before they can go down this waterfall and excite the corona to its tens of millions of degrees temperatures. And beyond here, there's a slight electrical field, just enough to accelerate the solar wind the way we see it. Of course, this then is a regulating mechanism, because just a small shift in voltage up and down here is enough to modulate the power output that passes through these tufts. And that is the regulating mechanism for all bright stars that have a photosphere. That's why they shine steadily in the night sky. There is no regulating mechanism for a thermonuclear model star. In fact, they're the most unstable things you could imagine because some of the reactions vary with temperature to the 5th power. Here are these strange things called spicules, and Ralph Jurgens didn't shrink from trying to explain these as well. And it turns out that to maintain a steady discharge through that tufted sheath, there has to be a balance between the number of electrons traveling one direction and the number of positive ions going in the other direction. And these spicules actually provide the material to be ionized in the chromosphere and maintain a steady discharge. There's an analog in some arc lamps, the kinds of things used in searchlights. They had porous anodes to actually produce this steady arc. Don Scott, this is his diagram from his book, The Electric Sky. It's the solar transformer. The greatest puzzle of the sun, its magnetic field reversals, is solved. The sun has magnetic fields induced by a varying DC power input, and so acts like a power transformer with an impressed DC current as well. So all you've got is a varying DC current, which is driving the sun. Remarkably, once again, here he is, Christian Birkeland proposed that solar magnetism was caused by electric currents induced in the conductive interior of the sun. Hey presto. He should have got a Nobel Prize, several of them. Solar neutrinos match the no thermonuclear engine inside the sun. It's not important, but it's just one of the questions that arise. Neutrinos produced in the dense photospheric plasma, because these are pinches, is where the nuclear synthesis takes place. So stars produce their own heavy elements. You don't have to have supernova explosions to do it. The supernova explosion actually distributes the material that the star has already formed. A neutrino count falls when the sunspots reduce the photospheric area. So the higher the number of sunspots, the lower the number of neutrinos, which is what you'd expect if this second point is correct. So we need not assume a change in flavour of neutrinos, whatever that means. In other words, a change in resonance state of the neutrino en route from the solar core, because the reactions in those plasma filaments is much more complex than the standard hydrogen to hydrogen chain reaction would provide. Now, stellar and planetary structure and composition are based upon the erroneous conviction that Newtonian big G is a universal constant. So when I say that this sun has a heavy element core, of course the helioseismologists would say, but you know, our models show that it hasn't. But they're basing their model on a completely erroneous idea about the amount of matter in our star or any celestial body. If big G is a variable dependent upon the electrical state or the electrical tension in a body like the sun, then we cannot say what it's made of. We have no way of knowing except by observing material that comes from it. And if the sun is cool, there is a radial internal electric field to be considered because, as I said before, all the positive charges are heavier than the negative charges. So in a gravitational field, there would be an offset and a radial electric field, so all celestial bodies behave like electrets. These internal electric fields can actually respond to disturbances and cause the ejection of large quantities of core material. In other words, form planets and moons and so on. The electric sun has a completely different picture. Here we have a cool core. We have an extensive atmosphere and an ionosphere at the top, and at the very top of that ionosphere is this global lightning or electrical tornado system, packed cheek by jowl. Then above that you have the energy flow, and of course it's normal to expect that incoming electrical energy will excite the plasma out here first, and then as it gets into the more dense atmosphere it will exhibit discharge activity. Out here it's a coronal glow. In here, it's normal electric arc phenomena. So the energy to heat the electric sun comes externally from the galaxy. The electric discharge becomes intense close to the sun, heating the thin atmosphere of the corona to millions of degrees. And the superheated corona is a familiar glow discharge phenomenon recognized by high voltage engineers. Now we come to the HR diagram. It's based on observations. It's not based on theory. It's a scatter plot, not an evolutionary plot. And the luminosity and colour of a star depends on its size and the current density at its radiating surface. Discontinuities exist. You've got white dwarfs over here, red giants here, and red and brown dwarfs, which are all discontinuous with the main sequence. These are all stars with bright photospheres, so they have that regulating mechanism. Of course, the astronomers got it back to front. If you do a mirror image, then you have a more understandable arrangement where the stars get brighter and bluer as you increase the current density, so that you get this straight line curve, which is exactly what you'd expect. Red stars have to expand. That's both red dwarfs and red giants. They're stars which are not collecting enough electricity to satisfy the discharge, so plasma adjusts. It's like a living thing almost. It adjusts to its environment. And so it expands the anode sheath to collect enough current. And some of those anode sheaths are monstrous. You know, Betelgeuse, if that star was in our solar system, its photosphere reaches out to the orbit of Jupiter. White dwarfs, on the other hand, may be normal sized star, but they have no bright photosphere. Their upper atmosphere is in direct contact with the plasma of space. They have only a faint white corona. Imagine if the sun's photosphere turned off, you would see this white envelope, very faint, but very white, very high temperature in appearance. So stellar evolution is a fairy story. This is V838 Monocerotis. This erupting star transformed itself over a period of months from a small underluminous star, a little hotter than the sun, to a highly luminous, cooled supergiant star undergoing rapid and complex brightness changes. This was the quote of the article describing it. The transformation defies the conventional understanding of stellar life cycles. It's a very complex story. I've been through it, the theory of it. So here's a red giant. This is actually Betelgeuse. It's 500 times the size of the sun, and it has a hotspot. You've got to ask yourself, hey, what's a hotspot doing on a red giant star? What happens is as that envelope expands, the electric field grows stronger because it's trying to collect electrons from space. But on the other hand, positively charged particles, in other words, its stellar wind, are accelerated more strongly the other way. So you have this anomaly where these cool stars have the most powerful winds known. And if the stellar wind is being boiled off, so to speak, this doesn't make any sense at all. And Betelgeuse spots a hotspot. I've suggested it may be above one of its poles because one of the Alphane circuits shows that one of the connections of the electric circuit is to the poles of the star. So we may be staring at one of the poles. Giants and dwarfs. The usual story is that stars consume their fuel and change to giants or dwarfs. The story is complex, unverifiable, and regularly contradicted. This is another version of the HR diagram there. And astronomers are perpetually astonished by unexpected changes in stars. This is a white dwarf system. Sirius B is the white dwarf, and Sirius A, you'll see an optical light here. Sirius A is very bright in the sky, and Sirius B is almost invisible, and it's a faint white, so-called white dwarf. Now, if you look at it in X-rays, it's the reverse. Here's Sirius B, it's brighter than its optically bright partner Sirius A. This is what you'd expect, where the discharge reaches into the ionosphere directly of a star. The X-ray output is high, the visual light output is low. There's nothing special about that. It can be an ordinary star. It's just that its partner may have usurped most of the current. It's supposed to be a collapsed star at the end of its fuel. But how can an old and a young star be together? Because here you have an old and a young star, so to speak, under the conventional ideas, together. A white dwarf has no bright photosphere. Its white light and X-rays come from an intense corona. Here's the different star types, and I've shown how I think they would look. A red dwarf is actually quite large. In other words, it's like a red giant in miniature. a red dwarf was discovered, and the astronomers decided it was putting out too much light for what they assumed was a dwarf star. So they said, oh, it must be a pair of red dwarfs of exactly the same size and power output. I suggested, no, it's a single red dwarf. It's just much bigger than anyone ever expected. Main sequence star, it is covered with photospheric tufting, tufted anode and a controlled discharge. Blue giants are a large star under high electrical stress. Red giants are a normal star under low electrical stress, and it develops a glowing plasma sheath. A white dwarf is a normal star in direct contact with space plasma and has low luminosity. Talking about brown dwarfs, if a brown dwarf gets close to a very bright star, the bright star is at a higher potential than the brown dwarf. That brown dwarf will actually switch off as a star and become a comet. It switches from being an anode in the discharge system to being a cathode, and there are quite distinct differences. Now, if the Earth, hypothetically here, if the Earth was a satellite of a brown dwarf, that radiating shell would be quite enormous. It could have all of the satellites of that object, that small star, orbiting within that envelope. That whole radiating envelope puts energy on the surface of any orbiting planet equally on every square metre. So that you would have no seasons, no day and night, and you'd receive ultraviolet light. This refers to what Duardo was talking about the other day with the earliest memories of mankind. It suggests that we were in this situation, and astronomers in recent years have come to the conclusion that this is the more likely place for life to thrive. Where we are now is much more precarious. So brown dwarfs don't hang out with stars because electrically it's impossible. The other thing is that these brown dwarfs, unexpectedly, they flare. They throw material off occasionally because they've got no means of controlling their discharge other than to get rid of material, matter, charged matter. So that any satellites of these brown dwarfs gets occasionally drowned in water, an atmosphere, and also solid materials to cause layering on them. Brown dwarfs flare and deposit layered minerals on their satellites. There's a few more logical leaps involved in the electric universe, and I'll just go through a few of them. I asked the question, is gravity a weak electric dipole-to-dipole force between distorted subatomic particles? And this refers to something that Velikovsky said to me when I visited him, and also to Ralph Sainsbury's view that all subatomic particles have an orbital structure, a resonant orbital structure. And as Ralph has pointed out, magnetism then is also an electric dipole-to-dipole force due to transverse distortion of electrons or protons accelerated in an electric field. If so, the electric force is the only force necessary in physics, and this goes back to the way classical physics operated by trying to reduce the number of forces and ideas. And quantum effects imply that all matter has a resonant electrical substructure. Information and energy can be stored and transferred via these matter resonances, and that has significance in biological systems too. So astrophysical and biological coherence requires universal, near instantaneous electrical interactions. All of the so-called spooky quantum things are no longer spooky if we accept this idea. We have a return of the ether. We must have particles to be able to transfer the energy and the forces through so-called empty space. Empty space, I suggest, is full of neutrinos. Neutrinos are the lowest energy state of matter. They exhibit vanishingly small mass. They're composed of subtrons, which is what Ralph called them. They form electric dipoles, that is the neutrinos, in an electric field. And each dipole rotates in the electromagnetic field of a light wave that ties the speed of light in a vacuum to the moment of inertia of a neutrino. And neutrinos may reintroduce cause and effect to radioactive decay. At present, it's a purely statistical phenomenon. The other thing is that it also solves the difficulty of the so-called annihilation and creation of matter in particle accelerators. You cannot do it, but if the neutrinos are the substrate, they can accept energy and become a particle and its mirror particle. I don't use the word antiparticle because there's no such thing. It's all matter, all matter. I put these few slides on the end because there was discussion about Venus and the transfer of charge, and I think it's important because returns Velikovsky's gauntlet to him cordially. Velikovsky argued that planets change orbits, exchange thunderbolts, and quickly settle into peaceful orbits. Now, rapid settling after chaos defies Newton's laws, which, of course, that was the argument levelled against Velikovsky, which for more than a two-body gravitational system are chaotic anyway. So the astronomers have yet to explain why we have a stable solar system. So astronomers simply ignored the gauntlet flung down by Velikovsky. Then we have Anthony Pratt and the convergence of his work with ours some few years ago. And he showed, globally, petroglyphs show to a high degree of confidence that within human existence, the Earth has suffered stupendous electric discharge phenomena from the heavens. And that's a picture of one of his papers. Now, if we accept Velikovsky's gauntlet, we need to look at Newton's law of gravity again and just have a think about what it really means. You'll notice there that G, I put its dimensions there just to show that it does include mass. And if mass is a variable, then we have a problem. It is simply assumed that G is the same for all bodies in the universe. In other words, the universal gravitational constant. That was an assumption. Stellar and planetary structure and composition is based upon this premise. But if mass is a variable, can it explain cosmic pool? The book over there is by one of the Thunderbolts team, C.J. Ransom, The Age of Velikovsky. Of course, MOND is the latest buzzword in gravity theory, the modified Newton's dynamics. I've suggested that we can have electrically modified Newtonian dynamics. And I won't go through all that business there, you can see it on my website and so on. But the upshot is that the radius of the orbit of the planet is proportional to the mass of the planet if you keep the orbital energy constant and you assume the sun's G is constant. I think that's a fair assumption. If the mass doubles, the orbital radius must double to conserve orbital energy. Now, I said earlier that all planets and stars and all celestial objects will form an electret. In other words, you have positive poles facing inwards and negative poles facing outwards. So it sets up an internal electric field. The planet acts like an electret. And any free electrons would tend to drift towards the surface. Like a subatomic particle under the stress of an electric field, the internal electrical stress modifies the apparent mass of the planet or star, and therefore its gravity. Exchanging charge at the surface through lightning, etc., changes the mass or gravity of a planet. And there is evidence for that. Coronal mass ejections, large ones which strike the Earth, actually change the rate of spin of the Earth suddenly, and then it decays back to its original speed, which is diagnostic of a change of the moment of inertia of the Earth by some means which hasn't been explained. Comet accelerations also. Cometary displays are an obvious electric discharge phenomenon. Any body on an eccentric orbit about the sun will experience discharge activity. The discharge will cause apparent non-Newtonian acceleration, and this is well known with comets. They're very hard to predict their precise return because of them. And this is because the mass of the comet is changing, something that's not taken into any account. However, gravity is still the operative force, but here we have a feedback mechanism which can modify orbits. So, changing planetary mass. The closer the encounter between two planets, and the more powerful the charge exchange between planets, the greater the orbital adjustments. It seems an efficient mechanism for collision avoidance and spacing the planetary orbits apart, which may explain one of the reasons why we survived Velikovsky's catastrophic scenario. The inner planet reduces its charge polarization, its mass, and the outer planet increases its polarization, mass, in the exchange. And I ask the question, is this possible? Yes, I believe it is. Because some years ago it was reported that a spacecraft here, the SOHO spacecraft, picked up stringy things, stringy plasma things, arriving from Venus when it was between us and the sun. Now those stringy things, of course, are recognized immediately as Vauquelin currents, and the Vauquelin currents transfer electrons from Venus to the Earth. At present it has little or no effect on the Earth because of the distance and the low current density. So there's an intermittent circuit for transferring electrons from the inner planet to the outer when they're aligned with the sun. The charge transfer is in the correct sense to induce the planets to move apart into orbits having electrical least interaction. Quickly, it will appear as though the system operates according to Newton's laws with no sign of recent instability. And that was the problem that Velikovsky faced, and it was the question I asked him when I visited him. How do we deal with this problem? And I think this is the answer, or part of the answer. And we come to the Sagnac Award winner, and I consider a great man, a modern Galileo. Dr. Halton Arp embraces a plasma universe. I think it's a very apt photograph. Also, I might say that a lot of interesting issues raised by Halton Arp's discoveries fit neatly in electric universe solution. For example, intrinsic quantized redshift and an increase of mass with time were explained by an electrical origin for particle masses and their resonant quantized states. Because the quasars are ejected from a galaxy, the electrons are tangled up in the plasmoid at the center of the galaxy for far longer than the neutrons, which can escape because they're uncharged, and the protons, which are heavier. So that quasars are electron deficient initially, which means that all of their energy levels of all their matter will function at a lower level. Their fine structure constant will be different. Their redshift spectrum will be enhanced. But over time, as the electrons stream out in those great jets that we see, both the mass increases, but it does so in resonant steps, quantized steps, and the brightness increases because the electrical energy arriving is increasing. And so this explains this very strange phenomenon where a quasar ejected at very high speeds from the center of an active galaxy can actually slow down and go into orbit about its parent. So this is the quasar mass gain. You can see this is one of Arp's diagrams of the birth and the development of quasars into companion galaxies.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Scientists today are expressing their surprise over the detection of water deposits on an asteroid that is thought to be pure metal. The asteroid is called 16 Psyche, and it's described as the largest metallic asteroid in the solar system. The co-author of a new paper on the asteroid says of the discovery, "We did not expect a metallic asteroid like Psyche to be covered by water and/or hydroxyl. Metal-rich asteroids like Psyche are thought to have formed under dry conditions without the presence of water or hydroxyl, so we were puzzled by our observations at first." The authors of the paper have suggested that the water was delivered by impacts from other asteroids in 16 Psyche's past. However, they have also considered the possibility that the water was formed by solar-wind interactions with silicates on the asteroid's surface. In previous Space News episodes, Dr. Franklin Anorexia, a specialist in electrochemistry, has proposed that a similar mechanism may be responsible for the detection of water molecules at Comet 67P. Today, we asked Dr. Anorexia for his analysis of this new discovery.
Observations indicate that comets and even asteroids appear to us to behave unexpectedly. This is partly due to the lack of complete understanding of cometary phenomena due to its complexity. I have previously proposed the presence of three competing mechanisms in action in cometary bodies for the identification of water and other organic volatiles. These are, number one, sublimation of volatiles from the nucleus due to solar radiation. This option applies once their presence on the surface of the nucleus has been confirmed. Number two, water formation on the surface of refractory materials, such as silicates, due to proton implantation through the solar wind. And number three, water and organic material formation driven electrochemically. This is realistic since charge separation, voltage differentials, the presence of electric fields, and ion reconcentration due to the electric fields have been reported, which allows for a serious consideration of this mechanism. Recently, it was published that asteroid 16 Psyche, which consists of mostly iron nickel metal and is thought to be the largest metallic asteroid on the solar system, may have traces of water molecules on its surface. The authors find that the near-infrared absorption features in the proximity of 3,000 nanometers can be attributed to the presence of water or hydroxyl ion. This is particularly relevant because a similar phenomenon was reported to be present on the surface of the moon. The deep impact observations of the moon not only unequivocally confirmed the presence of hydroxyl or water on the lunar surface, but also revealed that the entire lunar surface is hydrated during at least some portions of the lunar day. Therefore, it is reasonable to assume that this phenomenon is also hydrating asteroid 16 Psyche. Within the framework of a neutral medium, the corresponding reactions can be thought of as gas-gas reactions if they occur above the surface, and gas-solid interface reactions if they occur on the surface, which is normally called proton implantation. Collision theory can explain both reactions, mostly driven by kinetic energy gained by the particles from the solar wind or solar radiation. The authors state the detection of a 3 micrometer absorption band suggests the Psyche may not be metallic core, or it could be metallic core that has been impacted by carbonaceous material over the past 4.5 billion years. The infrared data is not clear-cut in terms of the definite presence of impacts over such a long period of time, but it's likely that such a statement is a reflection of the current dominant paradigm. In a non-neutral medium, one where there is the existence of a dynamic voltage differential, giving rise to non-zero electric fields, charged particles such as hydroxyl and protons can gain kinetic energy from the electric fields, resulting in the reconcentration of ions along the electric fields. Due to opposite polarities, these charged particles would be attracted to one another, and if their guiding electric fields cross paths, one can imagine a rapid and turbulent gas-gas reaction taking place, which could lead to large quantities of instantaneous water formation. In the absence of solar radiation or heat, these water molecules can migrate, redistribute, and condensate on surface. Nonetheless, of particular importance is that the surface of Comet 67P contains both the presence of small amounts of water on its surface and carbonaceous material. These are facts, and perhaps the same mechanism is an action on both bodies, asteroid 16 Psyche and Comet 67P.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.